Hello wonderful person, this is Anton, and in this video we're going to be talking about Venus and a new idea coming out of Goddard Institute for Space Sciences that suggests that it seems that Venus probably had water and habitable conditions for a very long time, and it also seems that these conditions only disappeared a few 100 million years ago. In other words, it's possible that Venus was habitable for billions of years. So for a very long time, most scientists have been kind of speculating that it wasn't just Earth that became habitable, but that it was also Mars and, of course, Venus. All three planets very likely were somewhat similar to each other, and in some sense may have even had very similar initial conditions for, well, essentially life. We know, for example, that Mars definitely had an ocean, and we even see very obvious signs of shoreline on the surface of Mars, including even signs of a mega tsunami that happened here. But at the same time, back in the late 70s, when the Soviets and the Russians launched their mission to Venus, specifically the Pioneer missions and also the Venera missions, this right here is one of the Pioneer probes, they realized that the surface of Venus, and more specifically the middle part of the atmosphere, had quite a lot of water vapor, and at the same time they also realized that Venus, despite being such a different planet today, was very likely very Earth-like at some point in history. And there are quite a lot of studies out there that do analyze the water vapor presence on Venus in a lot more detail, and also talk about Venus being a lot more Earth-like in the past, and most likely having a global ocean as well. But this particular idea that was recently presented in the Goddard Institute for Space Science investigates how long this ocean may have lasted, and also tries to identify when this ocean disappeared. Now, there is no actual paper out yet, it's only based on the presentation, and the paper will come out eventually, but here the scientists used several simulations, specifically 5 very specific unique simulations, to try to identify how long the ocean on the surface of Venus would last, and most importantly discover when it may have disappeared. And to their surprise, and let's actually maybe try to create an ocean here as well by modifying certain parameters of this Venus, they discovered that it's possible that ocean here only disappeared about 700 million years ago. And more specifically, approximately 715 million years ago, when something major occurred, something so dramatic and so catastrophic that it eventually released all of the carbon dioxide that was hiding inside of the planet. And following the so-called runaway greenhouse effect, the entire atmosphere became extremely saturated in CO2, very, very hot, and we got the planet we have today, which is the object you see right here, an extremely hot, very highly pressurized planet that doesn't really have any capability of supporting organic life. The temperatures here are 450 to 500 degrees Celsius, and the pressures are around 90 to 94 atmospheres. In other words, about 90 to 94 times more than on the surface of our planet. And these conditions were very likely created by this so-called runaway greenhouse gas effect. Now, what exactly happened here we don't really know, but we do have some ideas. So the way that it works, at least right now for Earth, on our beautiful planet, the CO2 and a lot of other greenhouse gases are more or less controlled. In other words, they're reduced by something. And here on Earth, a lot of the CO2 gas, and actually most of the CO2 gas, is actually not in the atmosphere. It's inside ground. It's basically deposited inside the rock and has been there for a very long time. The vast majority of CO2 is literally underneath us. And the thing is, there is a way for it to be released, usually through volcanic eruptions. And you can actually check out some of the older videos, specifically the one that might be above my head right now, that does talk about the amount of CO2 inside Earth. But just to give you a summary, if you were to release all of it into the atmosphere, the pressures here would be pretty much even higher than on Venus, and the temperatures would be dramatically higher as well, close to about 1000 degrees Celsius. And so all of this CO2 is stored there, and only major volcanic eruptions, such as, for example, the eruptions of the Siberian traps that occurred in Siberia around 250 million years ago, and here the word trap simply means steps, which refer to the very unusual formation that you can see in this picture right here from India, or in this picture here, all of these were formed by volcanic traps. Now, Siberian traps that were tremendously large and located in this area right here, although let me show you on the map instead. So this right here, these traps, these volcanoes were so large and so powerful that they caused an actual extinction, one of the biggest extinctions ever. And today we believe that all major extinctions can be correlated or associated with some kind of a major volcanic eruption. And even the one that affected dinosaurs 65 million years ago happened around the time of a very major eruption in India known as the Deccan Traps. The location for which is right here in purple. So this extremely large eruption happened around the same time as the passing of dinosaurs, which means that many scientists for the longest time argued that it's probably the volcanoes that killed them, not the actual asteroid. But today we believe that it's very likely that it did start with the asteroid, but the volcanic eruption in India basically finished the job. So the volcanic eruptions of this proportion are usually enough to start releasing a tremendous amount of gases into the atmosphere, and more specifically the CO2 gas. And if such volcanic eruption releases a very large amount of CO2, it can suddenly and quite dramatically change the entire face of a planet. And so the scientists behind this presentation and behind the study believe that something like this must have happened on Venus. Now, we don't really know what caused it. We don't really know exactly how all of it started, but it's possible that roughly around 715 million years ago, something occurred on Venus, and here we can only speculate what it was, but there is a suggestion that maybe it was actually a crash. This isn't really coming from this particular study, but it has been investigated by other scientists. And this crash, which may have occurred around 750 million years ago, then initiated a kind of a chain reaction. Following the collision with whatever it was, or possibly some other catastrophic event, pretty much all of the volcanoes, or all major volcanoes on Venus, kind of activated. They started releasing a large amount of atmospheric gases, and we believe that this may have led to the end of Venus as a habitable planet. Now, it doesn't have to be a crash to cause this. It could actually be just the volcanoes themselves that suddenly triggered all at the same time. But we don't really know what can cause such a tremendously powerful eruption to literally annihilate the entire planet. I guess the biggest worry here is that it could happen on Earth one day. Now, there are several papers investigating the correlation between major volcanic eruptions and potential crashes. So, like I mentioned, the Indian Deccan Trap volcanoes did occur around the same time as the catastrophic asteroid that started the demise of dinosaurs. And so there are papers suggesting that by experiencing this collision, Earth's volcanoes on the opposite side of the planet literally triggered and started releasing a large amount of gas that then added a lot of various materials to the atmosphere that then changed climate and caused the dinosaurs to completely die out. And so we're not sure if this is what happened on Venus, but what we're certain about is that it definitely changed dramatically. This change, if it did occur about 750 million years ago, was quite sudden and quite, I guess, in some sense unexpected. But what's more interesting here is that prior to this change, Venus was very likely a very Earth-like planet. The average temperature here would not be really as low as Earth, but it would be a relatively comfortable, maybe 20 to possibly 50 degrees Celsius. And so it's quite possible that prior to this unusual catastrophe, Venus's temperature was in the range of about 20 to 50 degrees Celsius, and the conditions could have been very similar to Earth, although a little bit hotter because Venus is closer to the Sun. And in the simulations that they ran for this study, they've even tried to simulate a planet where it was literally covered in water, approximately 158 meters on average in depth, and the simulation where there was very little water. And all of them had very similar results, with the sudden changes in conditions around 700 million years ago. And in all of those situations, you get pretty much the same result. Eventually, the water disappears, and Venus then sort of turns into this very inhospitable planet that it is today, with extremely hot temperatures and pressures. And although the scientists behind this study didn't really go into the details of how they think it happened, they do speculate that it probably has something to do with magma on the inside, not so much as the actual asteroid collision. So in other words, it's basically anyone's guess what happened. Until we actually go to Venus and try to investigate some of the details by landing here and by somehow trying to survive long enough to study the actual rock, we're not going to be able to answer these questions. But why is this important? Well, it's important for one reason. If sometime, a long time ago, Venus looked like this, and now it sort of looks like this, and is basically no longer capable of sustaining life, what went wrong? How do we avoid this from having this here on Earth? Because Venus is so similar to Earth in many different ways, just a little bit smaller, we definitely want to avoid this. And trying to understand what happened here and to prevent this sudden release of CO2 and to keep planet like this is very important for the survival of life on our planet. And so this study is actually very important. If this was an asteroid impact, we have to try to understand how to prevent large asteroids from hitting our planet in the future. If this was some kind of solidification of magma on the inside that we don't really even know how to prevent right now, we then need to find other ways of managing this if it actually happens in the future. And since of all the terrestrial planets in our solar system, really just one is capable of hosting human life, we need to make sure that we maintain it this way, and we need to understand other planets and what actually went wrong here to try to prevent this from happening to our planet. And at the same time, this study may also help us understand if life did exist on Venus, and possibly maybe it even somehow transferred to Earth afterwards. So all of these questions will one day be answered, but for now we just need to send more probes and study a little bit more of both Venus and Mars to try to understand what actually happened to both of these planets. Hello wonderful person, this is Anton, and today we're going to be talking about the hottest planet in the solar system, Venus. But more specifically, we're going to discuss the possibility of life here, especially based on some of the more recent studies. So imagine an object that is so extremely hot, acidic, and filled with so much pressure that even the toughest Soviet probe only survived here for like 2 hours max. As a matter of fact, that probe was able to take a picture that sort of looks like this after processing. So this is Venus, the hell of the solar system. How could we talk about life possibly existing here? Well, when the Soviets discovered that the temperatures and pressures and the acidity here was just too extreme, they more or less abandoned further missions. They realized that no life will probably be found here. But in 1963, Carl Sagan wrote a very interesting paper proposing that even though on the surface of Venus there might be no life, we could potentially find something in Venusian atmosphere. And he even identified a region in the Venusian atmosphere that is currently referred to as the habitable zone of Venus. This habitable zone is anywhere between 47 to about 70 kilometers of altitude, and essentially it's the region where we can technically expect temperatures and pressures very similar to those right here on Earth. Anywhere between -20 to about 65 degrees Celsius, with pressures of about 1 atmospheric pressure, and the only problem being, well, a lot of acidic clouds more specifically. But that never really stopped some of the bacteria here on Earth. As a matter of fact, in one of the recent videos I talked about the extreme waters and lakes of Dahlul's volcano, which have some of the highest acidity possible actually. It's basically pH of 0, and very high temperatures and also a lot of acidity. And many lakes here do have life. Some don't, but many do. And this suggests that some of the more extreme bacteria could technically survive in those upper layers of Venusian atmosphere. And the thing is, there are a lot of signs pointing at some unusual, strange activity in the Venusian atmosphere. More specifically, we have recently discovered what seems to be climatic changes, or basically something equivalent to, I guess, seasons of Venusian atmosphere, where the temperature and also, most importantly, these unusual patches do change in size depending on the year. And today many scientists actually think that the unusual dark patches that have been observed inside the atmosphere, or the so-called dark UV absorbers as they're also known, could maybe be caused by some sort of a bacterial organism that is absorbing the UV light and is using it for its life purposes. In other words, there is currently a lot of scientists believing that Venusian life could actually exist in the upper atmosphere. Now, this would not really be a surprise because we do have bacteria living in our atmosphere and even upper atmosphere. While at the same time, even though technically Venus currently looks like this is a composite shot taken by the Venera missions back in the 70s. Once upon a time, we think Venus looked very much like Earth. It had oceans, it had very likely a lot of atmosphere, possibly oxygen, and for all we know, it may have had life. And if some of that life survived, it could now be thriving in the Venusian upper atmosphere. And so the most recent study assumed that there could be life here and decided to investigate if it can survive other dangerous to life phenomena, such as, for example, the cosmic rays that strike Earth and of course Venus from every single direction. So we know that cosmic rays and radiation can easily destroy life, and because it comes not just from the sun but also from the actual space around us, it could destroy any life that is trying to survive in Venusian atmosphere if there's a lot of radiation there. But because Venus has such a thick atmosphere and because it's so close to the sun, it generates this unusual phenomenon known as the induced magnetosphere, sort of by accident. Basically, when the solar wind, because of its power close to the sun, strikes Venusian thick atmosphere, it creates charged particles which then cause Venus to have a little bit of magnetosphere, but possibly enough to protect some of the life if it exists in the atmosphere. And so the scientists behind this recent paper that you can find in the description below decided to investigate, assuming that life is in the atmosphere, would it survive the radiation? And they decided to look at bacteria such as this bacteria right here, which survives in really extreme environments. This bacteria is known as Shevonella oneidensis, and it's very interesting to science because it doesn't seem to need oxygen or a lot of other materials to survive. It can thrive in metallic or sulfur-rich environments, and it can also even help us extract some of the metals if we ever decide to go and explore other worlds. But the most interesting part about it here is that it could easily survive in the conditions of the so-called habitable zone in Venusian atmosphere. The only other danger to this bacteria would be radiation coming from cosmic rays. And if it can technically survive the cosmic rays, there would be almost no reason for us to assume that something in Venusian atmosphere could destroy bacterial life. And by analyzing various conditions and various doses of radiation, the scientists behind this paper basically came to a conclusion that there is not enough radiation in the Venusian habitable zone to harm Shevonella oneidensis. In other words, most bacteria similar to this one would easily survive in Venusian atmosphere, and despite acidic clouds, would very likely thrive in those conditions. There's a lot of material there, there's a lot of sulfur, there's a lot of what would be equivalent to bacterial food, and any bacteria that's present in the atmosphere of Venus could definitely adapt to these conditions and even use the UV light coming from the sun for its own purposes, which is maybe what we're observing with these strange unexplained UV dark patches that scientists have been witnessing in the last few years. So far there's really no explanation, no chemical explanation for what we're observing, but many scientists believe that maybe a bacterial colony of an extremely large size could explain what we're seeing. Essentially Venusian life, but not on the surface, in the clouds. And interestingly, the Venera missions and also the Magellan and Pioneer missions that came to Venus roughly around 40 years ago discovered a lot of interesting materials here that are used by life here on Earth. For example, the Magellan mission discovered different types of carbonyl sulfides. We also discovered a lot of hydrogen sulfides, sulfur dioxide, and all of these materials are used here on Earth by life to produce energy. And so there's no reason for us to believe that Venus is incapable of also hosting life, but slightly different from life on Earth. Now, unfortunately, no major mission is really being planned to Venus anytime soon, and the only currently functioning probe around Venus is the Japanese Akatsuki that is currently mapping and exploring the Venusian atmosphere in a little bit more detail. It's also trying to discover any kind of sign of lightning, for example, and hasn't really seen anything. It seems like there's no lightning on Venus. But anyway, that's something we'll talk about in some of the future videos. What is important though is that we don't have any missions planned to try to discover if what we're seeing on Venus is life. Because there might be alien life very close to Earth, the closest planet to Earth, Venus. But currently we're really just planning missions to Mars and not Venus. Although interestingly, last year NASA awarded about $120,000 to one of the teams to try to develop something similar to what you see on the screen. A kind of an autonomous flying drone that would stay in the atmosphere and try to discover something alive. But the thing is, this is still in really early planning stages, so it would probably be at least a decade before we develop anything equivalent to an actual mission. For now, we only have Akatsuki and its beautiful pictures. But anyway, what's important from all of these studies is that there are clear signs that something is going on in the atmosphere of Venus, and all of these signs point at bacterial life. Unusual life that seems to affect the atmospheric conditions on Venus and also seem to visually change the appearance. And if we're lucky, in the next few years, we might discover what exactly is causing this. But until then, that is all I wanted to mention in this video. Let's finish this video on this beautiful image of so-called Mount Mons, the 8-kilometer high volcano, the image for which was created by the Magellan mission many decades ago. Hello wonderful person, this is Anton, and in this video we're going to imagine going back in time and taking a look at our own solar system, looking at what it may have looked like approximately 3.8 to 3.7 billion years ago. Some planets will actually be quite similar, but some will really surprise you. Depending on how many videos you've watched on the channel, you may actually already know what we're going to talk about. There's a video I made a few years ago where I actually looked at each individual planet as it was several billion years ago, and some planets actually haven't really changed that much. As a matter of fact, for the most part, the gas giants and the ice giants here will still look kind of similar, maybe slightly different, but not by much. And one of the reasons I picked this specific date is because approximately 3.8 billion years ago was when the period known as late heavy bombardment was about to come to an end. That's a period when there were quite a lot of various leftover rocks left in our solar system that started colliding with pretty much everything in the solar system. These were the leftovers after the creation of the solar system itself. For gas giants though, as you can probably see, it doesn't really affect them that much in terms of at least visual appearance. A lot of these rocks will create a lot of energy when they collide with, for example, Jupiter, but the appearance of the planet itself will not change very much. And so Jupiter, Saturn, Neptune, and Uranus very likely haven't really changed dramatically. But the terrestrial planets did change quite a lot, as a matter of fact. Now, for example, Mercury is a good example of seeing what it may have been like, because the craters on Mercury haven't really actually dissipated that much, and so for the most part, it very likely looked something like this. Essentially, it was a lava world covered with quite a lot of remnants of collisions, and was very likely even hotter than it is today, and possibly had some liquid water that evaporated pretty quickly. Now, for the most part, that's probably the most sort of exciting time for Mercury, because it had quite a lot of active things going on the surface, and it may have even had a slightly thicker atmosphere because of all of the collisions and all of the stuff that was released because of those collisions. But overall, because Mercury is so small in comparison to other planets, and also because it doesn't have much gravity, as soon as it cooled down and as soon as things started to settle, it essentially evaporated. A lot of the atmosphere disappeared, a lot of water will disappear as well, and pretty much nothing was left except for the actual signs of this really dramatic past that Mercury experienced. Now, the other three planets that we're going to talk about were most likely completely different from what they are today. Let's start with the more obvious one, our home planet Earth. So we actually are going to erase this version of Earth and put a completely new Earth that we're also going to terraform, giving it a little bit of atmosphere and more hospitable conditions. And for the most part, this is most likely what Earth looked like back then. We don't really know about the actual continents because it's very difficult to study what happened about 3.8 billion years ago in terms of the actual shape of the continents. But the planet was barren on the surface and had quite a lot of different bacterial life in the oceans. At some point, as I mentioned in one of the previous videos, the planet was also purple in color because the bacteria inside the oceans most likely changed the color of water to purple. And later on, it also became an ice bowl for several hundred millions of years, so it was actually completely white. But right after the so-called late heavy bombardment, it's most likely that the Earth will look kind of like this. As a matter of fact, it was a little bit less Earth-like than it is today. It was probably less hospitable. It most likely had very little oxygen on the surface. And if you were to take most of the life from Earth today and try to put it there, most of it would not actually survive. It was not a very hospitable place just yet. The oceans, though, were actually really great places to have life kickstart, but also to have life evolve pretty quickly. Now, how about Mars? Now, today we know that Mars actually had a very large ocean as well, and it's very likely that in that particular period of time, Mars was actually a lot more Earth-like than Earth itself, and it's very likely that the atmosphere here was pretty thick, enough to support liquid water. We actually do see the signs of very large ocean in the region that you see right here, and we also detect quite a lot of leftover water coming off the actual surface even today. As you know already, we've also discovered water underneath the surface of Mars, so this was a very hospitable place, and which is actually why a lot of scientists believe that maybe, just maybe, life also started here and maybe even transferred to Earth later on. This is the theory known as panspermia, but it hasn't really been proven yet, and unfortunately there is no way for us to prove it until we find an asteroid that shows signs of life somewhere out there in space. Now, interestingly, Mars was probably the most Earth-like planet in the region. As a matter of fact, it was most hospitable to life 3.8 billion years ago, and would actually be a very great planet to live on if it wasn't so small. The lack of gravity here, and also the lack of the actual metal at the core, meant that Mars lost its magnetosphere pretty quickly, and pretty much everything here, water and atmosphere and all of the air, slowly escaped, making Mars the dead planet that it is today. At least on the surface. It might actually have life inside, but we haven't really been able to discover anything yet. But we might one day. And lastly, let's talk about Venus. Now, Venus is also an extremely exciting place, and I'm going to try to transform it right now, just so you can actually see what's happening here underneath the cloud layer that's hiding the actual surface. Now, it's very difficult for us to estimate how much water Venus actually had, but we're almost certain that Venus too was a very Earth-like planet. And let's try to change it right now by putting just the right amount of water here and giving it just the right amount of atmosphere. So this is very likely what Venus may have actually looked like. Just like Mars, it most likely had quite a lot of liquid water on the surface. It also possibly had enough sort of temperature and atmosphere to support not just liquid water, but actual life. And for all we know, just like Mars, it may have had some kind of life. But because of the very slow rotation of Venus, and because it didn't really have a very active, geologically speaking, surface, in other words, it didn't really have any plate tectonics or a way for it to continuously fix carbon dioxide and keep it inside the actual planet, and at the same time circulate any kind of excess of CO2, eventually all of this CO2 started to actually come out. And we think that Venus, just like Earth, experienced quite a lot of volcanic eruptions that ended up releasing so much CO2 over time that was never actually fixed into the soil again, creating the Venus that we know today. So over time, it basically started to acquire more and more atmosphere, and eventually had so much that water evaporated, the entire planet got really hot, and became what it is today. It became this dry, super hot world filled with CO2 that was released from inside the surface. Now, Venus is actually an excellent lesson for us as well, because Earth, turns out, has way more CO2 than Venus did. And so if one day Earth actually loses its ability to fix CO2 and to keep it inside the soil, and if one day CO2 starts coming out to the surface as well, Earth is actually going to become even worse than Venus. It's going to become so hot that it's probably going to be glowing kind of like this. And so in a sense, Venus is actually quite a good warning for us, because it does show us what happens when CO2 goes out of control and creates this tremendously hot and tremendously inhospitable object. Now, for the most part, that's kind of all I wanted to show you in this video. I wanted to explore the idea of early solar system and show you what all of these terrestrial planets used to be like about 3.8 to 3.7 billion years ago. Hello wonderful person, this is Anton, and in this video we're going to be talking about our beautiful neighbor Venus. This is what it kind of looks like in Space Engine, and it sort of represents what it really looks like in real life as well. Today we'll talk about the discovery coming from Venus that suggests that Venus has really interesting climate and also climatic changes that we really didn't know existed. So this beautiful terrestrial planet is actually the closest planet to us, not Mars. At its closest, Venus approaches Earth at a distance of about 38 million kilometers, which is relatively close when it comes to planetary distances. But today our interest in Venus is in regards to its past, specifically in regards to its changes related to the so-called greenhouse effect. We believe that Venus has undergone a dramatic change in its past, going from, well, basically something that looked more like Earth with liquid water on the surface, to a tremendously hot, hellish conditions with very inhospitable surface, equivalent to, I guess, what you would literally call hell. Temperatures here are close to 500 degrees Celsius, the pressures are ridiculous, the atmosphere is also full of acidic elements, and so most of the probes that were sent here didn't really survive for very long. The only pictures of the surface that we do have all came from the Soviet missions back in the 70s. The so-called Venera missions were able to survive on the surface for just enough time to take a few shots, and were then most likely completely destroyed by the super high pressure and, of course, the temperature. And although the photos that we have are not super detailed, they do give you an idea of what it's like on the surface. Now, if you'd like to explore these photos, I'm posting the link for this website that was created by Don Mitchell quite a while ago, over a decade ago actually, and he does have these really well reconstructed photos from the Soviet mission. But even though one day we would like to go back to Venus and possibly take a few more shots of the surface, it's really the atmosphere of Venus that's the most interesting part to us right now. And more specifically, this composite shot right here, taken by the Japanese Akatsuki mission, gives you an idea that there's something happening in the atmosphere of Venus that we can't really explain just yet. There are these dark patches pretty much everywhere, and these dark patches are not really simply just clouds or any other formations that are easy to explain. They do have properties that we've only observed in some features on Earth. Specifically, they seem to actually change the ultraviolet absorption of the planet. In other words, some of these dark patches in the atmosphere of Venus, as they travel around the atmosphere, they either increase or decrease the UV light absorption, and this does influence the atmosphere quite a lot. Now, one thing you need to know about Venus, and here's maybe a slightly better view of this, you can't really see its surface. Pretty much about 90% of all of the light that comes to Venus is reflected. It has a very high albedo, and the word albedo refers to the reflectivity of an object. So obviously things like mirrors, for example, have very high albedo, whereas things like black roads will have very low albedo. And the albedo of Venus is so high that if we were to make it similar to albedo of Earth, the temperature on the planet would jump dramatically. So right now the temperature is shown at 475 degrees Celsius, and just for fun, let's actually decrease the albedo to what it is on Earth, which is roughly around 35%. And look what happens to the actual planet. It becomes a lava world. It literally lights up, it melts, everything becomes ridiculously hot. And so the atmosphere itself, even though the planet is already super hot, and even though the greenhouse effect influenced the temperature on the surface, still kind of protects the rest of Venus from becoming a completely molten world. So this is why, for us, it's interesting to find out what's really happening in the atmosphere. And since 2007, we've been actively studying the atmosphere and discovered that the reflectivity of this planet is correlated with the number of these unusual dark patches. And we're still not really sure what they are. These scientists currently refer to them as unknown absorbers, and the explanation differs from them being some sort of particles, some sort of aerosols, possibly something related to oxides of sulfur, or maybe some kind of a ferric chloride, or essentially something that can influence the absorption of ultraviolet light. But late Carl Sagan even suggested that there are some similarities to bacteria living in the atmosphere of our own planet that seem to actually have very similar features. In other words, he even suggested that this could be signs of life in Venusian atmosphere, simply because of the properties we're observing. But what is really unusual is that as these patches were changing, so was the absorption of the ultraviolet light. As a matter of fact, since 2007, the absorption of UV light on Venus halved, but then it started going up again. And so that's exactly what this recent paper talks about. What they did is analyze the data from these different missions and discovered that the changes in the dark patches in the Venusian atmosphere were correlated with the changes or actually heating of the atmospheric layers, and thus most likely the increase of the wind speed. And the winds on Venus are already really fast. The speeds here can reach up to about 300 kilometers per hour. And this is due to a phenomenon known as superrotation, where even though the planet doesn't spin, the winds above it rotate, or technically move, really fast. And today, or at least now, because of this paper, we believe that all of this is related. So these patches, wherever they are, whatever is in them, are causing the planet to drop its albedo and then absorb more light, specifically UV light from the sun, which heats up the atmosphere, accelerates the winds, and creates, I guess in a sense, summer. So technically the conditions in Venusian atmosphere change very periodically. And according to the observations from this paper, these changes happen roughly around every decade, or around 12 years or so. And so this suggests to us that Venus has these climatic changes every 12 years, which we have never known existed and which we couldn't really explain before. But this of course creates a lot more questions than answers. And it's of course interesting that these dark patches relate to all of this, but what are the patches? What are they made out of? And this of course means that we need to go to Venus, we need to find a way to explore the atmosphere of Venus, and potentially find a way to launch some sort of an atmospheric probe that can study this in a little bit more detail and maybe discover if it's life or not. And this is really the important part, because if it is life living in those atmospheric layers on Venus, this would mean that life can survive much more inhospitable environments than we imagined. So here, even though the surface is ridiculously hot and extremely difficult to survive for anything really, the atmosphere, however, might have something for us to look into. And specifically, there are layers in Venusian atmosphere where the atmosphere itself and also the temperature is somewhat similar to what we have right here on Earth. Although not entirely chemically similar to what we have on Earth, because there are also things like acids and of course a lot of CO2 and absolutely no oxygen in those layers. Nevertheless, they could create conditions for atmospheric or aerial life. But what's even more unusual about this particular discovery is that the variation in climate that we've observed on Venus seem to be dramatically stronger than they are on Earth. In other words, not only does Venus have an extremely powerful greenhouse effect, it also seems to have very powerful climatic changes, with temperatures very likely changing by a huge amount. Every single, I guess you could call it winter, even though it's still hot, it's maybe not as hot as every summer. And this is of course not including things like storms, or I guess the gushes of wind that are present in the upper atmosphere of the planet that are already really strong stronger than pretty much anything we have on Earth. But what I find really intriguing in this discovery is the importance of albedo. Just to show you again, remember the albedo value for Venus is basically the highest of all planets in the solar system. It's at 90%. And this study really underlines how essential albedo studies are to discovery of new planets that are potentially habitable, to also analyzing atmospheres and analyzing atmospheric conditions. Because here, as soon as I change albedo by about 10%, the temperature of the planet changes so much that a lot of the atmosphere disappears and you can actually peer through the atmosphere. And this shows you the power of this property that's very rarely talked about. So here the temperature jumped by about 100 degrees when I changed the albedo by only 10%. So the reflectivity of objects is an important study. This is how we usually study the properties of objects that are far away. But it's even more important to study around objects like Venus, because obviously here, since 90% of light is reflected, even a tiny deviation from that makes the planet dramatically hotter. And since we're not entirely sure what really caused all of this and what's causing the changes in these unusual particles, or basically reflectivity of the planet, trying to identify the source is very important. There are suggestions that maybe it's because of the cosmic rays, maybe the actual cosmic radiation or the activity of the sun itself causes the changes in reflectivity of Venus. In that case, well, it's a lot easier to understand and a lot easier to simulate. But right now, the changes we've detected are not really connected to the so-called solar cycle. By the way, you can check out a video about solar cycles right there above my head. It's a very recent study that analyzed them in more detail. But either way, a very exciting study, and hopefully this will help us launch a mission to Venus soon so we can explore this planet a little bit more. Unfortunately, there hasn't been a lot of talk about Venus, and there really haven't been that many missions to Venus. The major missions all happened back in the 70s when the Soviets went there, but since then no one really came. But still, studying what happened to this planet and also understanding its climate is super important so we can actually prevent this on Earth. We don't want Earth to turn like this, and we know Venus used to be very Earth-like before. So let's hope we can learn some lessons from Venus so we can preserve our planet as it is right now. Hello wonderful person, this is Anton, and today we're going to be talking about the sister planet of Earth, Venus. And more specifically about a very exciting mission that NASA is planning for the next few years, and the contest that was just run by NASA that had some really incredible designs and winners. But we'll also talk a little bit more about the planet itself and why it's an exciting opportunity for us to advance science and potentially find an incredible object for us to colonize. But I wanted to start with a little bit of history. This right here is what's known as the Vega probe. This was a Soviet probe launched in the 80s that was the last attempt by the Soviets to land on Venus and essentially try to retrieve as much data as possible. When it comes to planetary exploration, the Soviet Union and Russia didn't really have a lot of luck with Mars. Most of the missions here were from NASA, but they had tremendous success with the partner Venus. And most of the information and most of the data we have about Venus is from the Soviet Union, from the Soviet space program. So for example, the first ever picture of the surface of Venus, along with the information on the temperature, the pressure, the composition, were all more or less accomplished by the Soviet Venera and other similar missions that were able to survive for a few hours on the surface of Venus. And early on, we realized how extremely inhospitable Venus was, not just to life, but even to the instruments sent to the planet. Essentially, nothing here survived for longer than a couple of hours, unless it was in the upper atmosphere. One of the last missions that Soviets were able to succeed in were actually part of the Vega mission you see right here, and were these extremely robust balloons with a lot of instruments and communication devices attached to them that would fly around the upper atmosphere, collecting all of the data and transmitting it via the orbiter around Venus. Now obviously this would have continued for a long time if USSR survived. We might have had even some sort of an aerial colony by now if we continue these missions, but USSR is gone, Russia is no longer continuing Venus missions, and other agencies including NASA have only now started to pick up where it was basically left a few decades ago. But honestly, the new NASA missions are absolutely brilliant. And they're brilliant for a very unusual reason. And what's important here is that it might lead to a creation of an incredible new type of technology that we've never had before. But more accurately, it might actually lead to the re-explosion of the so-called automata, or mechanical technology. Something that was created in the ancient world and mostly for entertainment purposes, and something that was actually created over 2000 years ago. Such as, for example, this right here. This is the famous Antikythera mechanism that was created most likely over 2000 years ago by the Greeks to try to predict the motion of the planets across the sky. But there were these unusual automata in very different cultures across the planet, and many of them were extremely advanced, but pretty much all of them were more or less only used for entertainment or recreation, not so much for actual science or any other productive reasons. Which is why the new NASA mission is so extremely exciting. It's not just entertainment anymore, it's actually trying to use similar principles to try to create an automata that can then be sent to Venus and explore all of its regions, all of its surface, by combining ancient technology with some of the modern research and modern technology. And that would definitely lead to the development of some of the more extreme electronics we've ever been able to create. But I guess the question here is, why can't we just send a regular probe on Venus, and why exactly can't it survive for a very long time? And the answer here: temperature, pressure, and a lot of corrosive materials on the surface of Venus that make any kind of electronics here last for only a few minutes, maybe an hour maximum. And even then, all of the data received from these electronics would be completely useless to us. Today, all of these silicon-based electronics can only really function at maximum about 150 or so Celsius. After that, they no longer work. So even if you were to cool down your probe dramatically, eventually the temperatures here will reach critical levels, and you will be stuck with a broken probe on this very inhospitable planet. One of the solutions here is to try to use some other material, like for example silicon carbide or gallium nitride, to try to produce electronics that can survive in higher temperatures. Here, the conditions that gallium nitride, for example, can survive is usually around 400 degrees Celsius, but Venus is even more extreme than that. So even though these electronics might be able to survive on Venus a little bit longer and could potentially create programs that are days long instead of being hours long, we're still really early in the development of these technologies, and only the studies from 2020 were able to create stable gallium nitride electronic devices that are still extremely primitive for what NASA needs them for. And so electronics for now are out of the questions on Venus. We have to use something else. And in this case, NASA realized that mechanical devices can definitely survive here. We just obviously have to figure out how to create a mechanical device that can not only withstand Venusian conditions, but can also then do everything else that a typical probe needs to do. It has to be able to navigate, it has to be able to sense everything around it, and it also has to be able to communicate with planet Earth. And so all of these challenges are now being addressed, and one of the missions that is trying to address all of them is this right here, the so-called ARI, or Automation Rover for Extreme Environments. But NASA realized that they can't really do this alone. In other words, they admitted to themselves that they were just not smart enough. They needed help from the public. So they opened a very interesting challenge known as Exploring Hell. And the idea was pretty simple. Submit your design, and in this case they were only looking for an idea for sensors to help this rover navigate the Venusian conditions and Venusian surface. Because for the most part, they kind of already have a lot of things figured out. Like this right here is going to produce energy, there's enough components on the inside to give it mobility, but they don't really know how to sense the environment. The rover right here does not have any ways to see where it's going. And there was also a prize of about $30,000 that was going to be shared between 3 winners. But despite this challenge not really being widely shared and also widely announced, it had a lot of different submissions. Over 6,000 as a matter of fact, with over 400 different teams joining in to try to win this. And the winners had some of the more brilliant and more original designs I honestly have ever seen. So I wanted to kind of highlight some of them. The first place went to Youssef Ghali, whose beautiful sensors you can see right here. It's all mechanical, it's all absolutely brilliant, and the way it works, I guess in some sense, blew NASA's mind. Youssef is an architect and a designer from Cairo in Egypt, and he calls this device Venus Feelers. Essentially, it allows this rover to feel any kind of a rock or any other device, and also relies on a relatively simple mechanical system that actually would be very cheap to produce, would be extremely easy to maintain, and would allow this rover to survive on Venus for a very long time. I'm also posting these winner videos in the description below, so check out the links because a lot of this is absolutely mind-blowing. The second place went to these two mechanical engineers from Santa Barbara in California, and it's a team known as Team Rovertronics. Essentially, they created something that looks like this. It's a device that can sense and feel the rocks once again, but using a very different type of a mechanism that is actually just as good as the previous model in being able to navigate around a rocky terrain. The third place doesn't have a video, but this went to Callum Heron of Brisbane, Australia for the so-called direction-biased obstacle sensor, DBOS. This sensor combines a type of a windmill with a Stirling engine on the inside and is a lot more sensitive compared to the previous two winners in terms of detecting rocks and other obstacles for this rover. Apart from this, there was also the best prototype winner, and this was Christine Burza and Oskars Burz. These two designers are from Latvia, and it's really impressive that they were able to create all of this in only a few weeks. And as you can see from this video, it works completely by itself. It has no person driving this, and it's all mechanical, it's all autonomous, and only requires this to make. So check out their video if you'd like to try to make this yourself as well. And the most innovative award went to Matthew Reynolds, a mechanical engineer from the United Kingdom, for his design known as Echoes, Evaluate Cliffs, Holes, Objects and Slopes. Here it creates a mechanical sonar, and this allows it to detect various large holes or actually even small holes in front of the rover, allowing it to traverse the terrain much easier. And so honestly, I am super excited to hear more about how this mission progresses in the next few years, and by the time we launch it, it's very likely that we might be able to combine the mechanical technology with some of the most advanced electronic technology that we currently are developing, be it either silicon carbides that you see right here, or gallium nitrides that might create electrical devices that are able to survive on the surface of Venus. Which is why I think this mission is going to lead to some of the most extreme new technologies we've ever seen. And with this beautiful competition that only cost NASA $30,000 might provide enough new advances for years and even decades to come. But this is only one of the missions that NASA and other space agencies are planning in the next decade, so there are definitely a lot of new things we're going to be talking about in some of the future videos. I definitely encourage you to check out the competition and the winners by yourself as well. All of the links for this are in the description below, and all of the additional information is there as well. But for now, we don't really know what exactly the mission is going to be like when it actually launches in the next few years. And we don't really know if it's even going to be successful, but just the fact that we're inventing new technologies just to meet this challenge already means that this mission has to go on. This mission has to continue because it will definitely help us develop something we've never had before. Hello wonderful person, this is Anton, and in today's video we're going to be talking about our beautiful planet Earth and a new discovery that seems to indicate that Venus and Jupiter seem to play a really large role in determining the climate on our planet. So in this climate simulation you can kind of see that a lot of the planetary surface changes over time with seasons. Every year you get winters and summers, and you get other seasons in between depending on the location on the planet. But our planetary climate is actually a lot more complex than this. As a matter of fact, we have other cycles, usually referred to as the Milankovitch cycles, that influence the climate on our planet on longer terms. For example, because of the way that our planet wobbles, in other words, if I look at the planetary alignment here, because of the way that it changes from about 23 degrees to about 21 degrees every few thousand years, the climate changes differently during those periods when the actual axis of the planet changes. This is one of the more commonly known Milankovitch cycles. We've actually studied this quite extensively and discovered that if you look at the sediments on our planet and if you actually dig into the planetary crust and you start looking at how the climate changed because of this, it actually becomes quite apparent that every few thousand years, and I believe it's actually something like 20,000 years, the planetary climate changes quite dramatically. So something like 23,000 years later, our planet will have relatively different climate. But a more recent discovery actually looks at something else. As a matter of fact, this is a very unusual discovery that happened pretty much completely by accident. We discovered a new layer of the Milankovitch cycle. And this cycle is formed by Venus and Jupiter. Now, you may not really see where I'm going with this yet, but basically Venus and Jupiter actually pull on our planet Earth and play a kind of a game of tug, where they actually change the orbital parameters of our planet every 405,000 years on the dot. As a matter of fact, it's one of the more stable Milankovitch cycles we've discovered so far, and it seems to influence our planetary climate quite dramatically. Now, what exactly do Venus and Jupiter do to our planet? Well, both of them actually pull with relatively similar strength on basically our planet, and they both change the planetary orbit to a relatively large extent depending on where these planets are located in their orbit. And what we discovered is that so every 405,000 years, the elliptical shape of our orbit, of the planet Earth orbit, in other words, the eccentricity, which I believe is somewhere right here, changes by about 5%, from pretty much circular like it is right now to more elliptical in approximately 400,000 years. And this cycle is essentially responsible for changing the climates quite dramatically. So if the eccentricity of our planet was basically 5% instead of just 1% like it is right now, the actual summers and winters will become dramatically different. Well, dramatically is a relative term. Compared to other planets, it's maybe not as dramatic, but here the temperatures will now start moving with a lot more extremity. So winters will be a lot colder and summers will be a lot hotter. And the scientists behind the study from the Rutgers University, specifically Dennis Kent, discovered that over the last 215 million years, this cycle was extremely accurate. So basically you can detect the changes in climate every 405,000 years, and they seem to happen no matter what else happens. So in other words, Venus and Jupiter have been pulling on our planet with pretty much the same parameters and same strength for the past millions and possibly billions of years. Now, what exactly does this mean for our planet? Well, in short term, pretty much nothing. On the short term, you probably won't even notice any climate changes because it takes thousands of years for this to actually become influential. But in longer terms, this is actually one of the many Milankovitch cycles that we have to be aware of, because this will actually change the face of Earth as humanity basically becomes more mature, and in the next few thousand years, the actual parameters of planetary orbit will change, and thus will lead to more extreme changes of climate. So you'll have more glaciation in the winter, and it might, as you can see here, even cause another ice age or several ice ages that will become cyclical as well. And sometimes those Milankovitch cycles actually align in such a way that you might get some really extreme climate changes. Like, for example, if you have the longest orbit or the most eccentric orbit mixed with something like very high orbital tilt, and possibly some more events that we're not aware of just yet. So this kind of shows you that when it comes to climate and when it comes to climate change, on long term at least, there is a lot of stuff going on, things that we're not even aware of. But obviously, one concern with the study is that this will probably give more fuel to climate change deniers. They'll basically start saying that this is all natural, not human-made. And, well, yes, it is natural, but the age and the years we're talking about here are way more dramatic than what humans have been able to do in the last few hundreds of years. As a matter of fact, the climate change that humans were able to influence in the last few decades alone are actually a lot more dramatic than thousands of years of Milankovitch cycles. So in that sense, climate change is also basically influenced by organisms living on the planet. And in this case, it's us. But as you can see, because I changed the parameters for our planet Earth and made its tilt much more dramatic and also increased its eccentricity, we suddenly now have another ice age in the northern part of the planet. This is what Milankovitch cycles usually cause every few thousand years. So this is a really cool discovery, something we didn't really expect to discover, and something that I personally didn't really realize until I read the paper. And what's really important to understand here is that it's probably not just Venus and Jupiter that are causing these cycles. I think as we study other planets, we'll discover that even Saturn and Mars might actually be pulling on our planet Earth in such a way that other Milankovitch cycles are being formed and influence our planet even more. So in that sense, planet Earth and the climate on planet Earth is still quite a mystery to us, and we still don't really understand everything about it. But until we study more and until we discover more of these Milankovitch cycles, we can't really say exactly what's going to happen in the next few thousand years. Hello wonderful person, this is Anton and welcome to Venus. In today's video we're going to be talking about more recent discoveries in regards to the surface of Venus and in what we now believe seems to be a type of plate tectonics that we may have detected on its surface. So here are the three sister planets side by side, with Earth in the middle, Venus on the right and Mars on the left. And we now believe, or I guess we've believed for a few years now, that all three used to look very similar billions of years ago. Specifically, O3 had liquid water, O3 had some sort of atmosphere, and most likely some sort of magnetosphere. And at some point, O3 used to be what would be now known as habitable planets. Now, for one reason or another, only Earth sort of stayed as Earth and basically remained habitable, and this is why we have so much life, including ourselves, on this planet. But Mars and Venus changed dramatically and took a very different approach, with Mars becoming a kind of a dry, dead world with basically no geological activity on the surface, only signs of geological activity, such as these volcanoes that you see right here, and of course the ridges as well. On the other hand, Venus has very thick atmosphere and it's really hard to see through it, but more recent discoveries showed us that its surface, and I'm going to try to show it to you right now by basically removing the atmosphere. Its surface seems to be covered with all sorts of ridges and all sorts of signs of geological activity, very similar to the ones on Earth and to some extent on Mars. So once again, this indicates that all three of these planets had a relatively similar surface and possibly even internal structure at some point in history. Now, very recent discovery on very recent study on Venus basically made a proposition that it actually is still geologically active, even though it doesn't look like it is if you just look at it. It seems that it has a type of a plate tectonic activity. Now, let me do a quick review of what plate tectonics implies. What you're observing right now is essentially a simulation of plate tectonics in action, where our continents and the place they're located on are moving around and changing the shape of Earth. Now, this is actually going back in time, so in other words, it's sort of in reverse. This particular video was actually made by a professor from Texas. I believe his name is Christopher Scortese. And in this video, you can kind of see how over time our planet has actually changed quite dramatically. And this is what we today refer to as plate tectonics. So here is another procedurally generated tectonic simulation by... I actually don't know who made this, as there's no contact information available, but I guess his name is Davidson. But anyway, so in this particular simulation, you can kind of see how over time, and we're gonna try to accelerate this a little bit, plate tectonics actually basically change the shape and the surface of the planet. In this particular case, it's basically a procedurally generated planet. Now, so we know that this is how plate tectonics work on Earth, and on Mars we thought that it had a kind of a similar idea called stagnant lid, basically implying that the whole crust is one continuous piece, and the plate tectonics don't really occur because it's essentially just one joined piece of shell. And we kind of thought that this is what's happening on Venus as well, but it turns out we may have been wrong, because we now discovered that Venus seems to have these parameters that indicate that there is some motion going on. And specifically, actually, here is a picture indicating some of the potential movements that have been detected in the last few decades, also suggesting that it's not really plate tectonics as we know it, but it's somewhere in between completely stagnant shell, where essentially nothing moves, and somewhat mobile crust that seems to be the case for Venus. In other words, if Mars had the completely stagnant shell where nothing moves, and Earth had completely active plate tectonics where everything moves, Venus was somewhere sort of in the middle where things move, but just not really the way we see them on Earth. Now, we are not entirely sure what exactly is happening on Venus, but we just know that there's definitely some sort of a tectonic activity going on, and it's very possible that this is actually something that happens on other exoplanets out there that we may need to investigate in more detail. Now, one of the reasons we think that this so-called crustal motion occurs is because the surface of Venus is very hot. Now, in this particular simulation, it's kind of low because I removed the atmosphere, but the actual temperature on Venus is on average about 462 degrees Celsius, suggesting that one of the reasons this crustal movement occurs is because the surface is already so hot that rock kind of behaves as a somewhat liquid-like material. And this also suggests that this might be actually just one of the stages of plate tectonics, and something that our own Earth may have experienced as well. Now, this study basically leads to a whole new idea of plate tectonics not really being fixed. In other words, it's not something that either happens or doesn't happen. It might be actually something that happens for a little bit and then stops and then occurs again. So Venus, for all we know, might actually be in this in-between stage. Whether it's going to have plate tectonics later or not is another question, but we know that Venusian surface actually does have some really extreme events happening every 300 million years or so, and there's one that's going to happen in the next few million years because it's sort of due for another such event. And maybe just maybe this will actually restart the plate tectonics on the surface, thus changing the surface of Venus completely. But this actually does have a lot of implications. One of them is that we now think that in the next 5 billion years or so, so basically when Earth is about 10 billion years old, it's very likely that the plate tectonics on Earth will also stop. And this will not be very good for our planet, because it will most likely lead to the same thing that happened on Venus, the so-called runaway greenhouse effect, where pretty much the entire deposit of CO2 inside our planet will come to the surface, turning our planet ridiculously, scorchingly ultra hot, possibly raising the temperatures to 200, 300, or even higher degrees Celsius. We're not entirely sure when this is going to happen. It's definitely not going to be anytime soon, but if it does happen, it's going to be basically the end of habitable Earth as we know it, and its face will more likely be similar to that of Venus. But this still doesn't answer the question what will actually happen to Venus. So when and if the Venusian crust starts moving around again, it might actually become more habitable looking. In other words, it might actually turn into something that looks like Earth. Or at least lose some of its atmospheric pressure and some of its temperature, and become easier to essentially terraform and turn into something that looks like Earth. For now though, that's all we discovered. We basically now understand a little bit more about plate tectonics, and just understand that it's not all or none event. It does seem to have an in-between, like it appears to have on Venus. And what happens next is obviously going to depend on when we come back to Venus and when we start studying it again. So for now, all our focus have been on Mars. And maybe, just maybe, we need to refocus our attention on Venus once again and try to discover as much about it as we can, because it is a lot similar to Earth. than Mars is. As you can see, Mars is a lot smaller and a lot more dead looking. Hello wonderful person, this is Anton, and today we're going to be talking about two different planets in our solar system that seem to share the same property: no moons. And I wanted to explain why neither Mercury that you see right here nor Venus have any moons anymore. And the important emphasis here is on the word anymore, because it's very likely that they did have moons previously. Many different objects in the solar system, and not just planets, have moons. For example, here's Haumea, the pictures of which were taken by Hubble telescope. Many different dwarf planets, including Pluto of course, have moons. And in case of Pluto, it has quite a lot of moons. So how is it that neither Mercury nor Venus have any? What makes these two objects unique and unusual? Well, in some of the previous videos a few years ago, I tried to explain this individually, but there are a lot of other things I didn't really explain in those videos, and today I wanted to combine all of them and explain them to you in two simple concepts related to orbital dynamics, and also briefly explain how all of this allows certain objects to have moons and other objects to have nothing, yet at the same time allowing some objects, like the other dwarf planet Haumea, to possess rings as well. So it all comes down to orbital dynamics and a lot of gravitational interactions. So first of all, both Mercury and Venus are slightly closer to the Sun, and in case of Mercury it's also a lot less massive than Earth. Here's how four of these objects compare to one another, and in case of Mercury it's actually easier to compare to our own moon. It's about 4.5 times as massive as the moon of our planet, which is already kind of weird, I guess. Mars, on the other hand, is roughly around 8 times as massive as the moon, so both of these objects have a lot less gravity on the surface, which is also why they're not really that good at holding other objects in their orbits. But Mars has two moons, Phobos and Deimos. Now, why is it that Mars has moons but Mercury doesn't? Well, one of the first questions we can ask here is, how do planets get moons? And right now we believe there are two main ways. One of the ways is by capturing moons. Like, for example, we believe that the vast majority of the smaller moons around Jupiter and Saturn, and also around Neptune and Uranus, are captured moons. They're moons that used to be asteroids or smaller objects, and eventually came too close and became captured. We also thought this was true for Mars, because its two moons are basically really small. They're kind of similar to asteroids. Here's, for example, what Phobos looks like. It's really small. But at the same time, we today think that this is not the case, and they were most likely created as part of another way of acquiring moons, through a collision. In this case, we know so because the orbits of the moons seem to align with the rotation of the planet, meaning that they most likely were created when something really massive collided with Mars and most likely caused a lot of other effects. But first of all, it very likely had rings. These rings eventually solidified, creating a lot of smaller objects orbiting around Mars. Some of these objects probably fell back, some of them became transient moons, some of them became Phobos and Deimos. With time, a lot of this sort of either disappeared and fell back onto Martian surface, but some of them survived and became Phobos and Deimos. This illustration was created by the Royal Observatory of Belgium, and it kind of gives you a really good summary of how a lot of moons, including the moon orbiting our own planet, were created and how they eventually evolve into these permanent objects. But we also know that both Venus and Mercury also had a lot of collisions, and these collisions are especially apparent if you look at the surface of Mercury. It's pretty much covered in collision impacts. And some of these collisions definitely suggest that this planet had a very active past. Venus is probably no exception. At least one of these collisions would definitely create some sort of a moon around Mercury. But what happened to them? Well, like I said previously, we think that they did exist. It's very likely that they existed, but they just disappeared for two simple reasons: the proximity to the Sun, and also this other really important feature that you can probably see right here in this simulation. The rotation of the planets is different, and this is really important when it comes to moons orbiting planets. As you can see here, both Earth and Mars have a relatively similar rotation speed. Earth does a single spin in 24 hours, roughly around 24 hours, and Mars does it in approximately 25 hours. On the other hand, neither Venus nor Mercury spin really fast. As a matter of fact, if we were to change this into one day being a single second, this is what it would all look like. These are really slow rotators. Now this plays a really important role when it comes to stability of moons. And here the best example is from our own moon. Because the moon and Earth have a kind of a gravitational relation toward each other, the pull from the moon causes Earth to have these two so-called tidal bulges. One of them is formed by the attraction from the moon, the other one is caused by so-called inertia. Because of this, and because the moon has a lot less mass, eventually the moon actually became tidally locked to Earth, which is why of course we always get to see the same side of the moon no matter where we are. If the moon was not tidally locked, it would sort of look like this and you would always get to see all sides. But Earth is more massive, and for the moon to tidally lock the Earth, it would take a lot longer, possibly up to about 10 billion years from now, and that's a really long time. And since Earth is not tidally locked, it rotates and causes this tidal bulge to shift just a little bit, making it so that it's always in front of the moon. And all of this causes a little bit of pull on the moon's front side. This pull causes the moon to slowly accelerate, and because of this, the moon is slowly receding away from Earth, roughly around 3 centimeters or about 1 inch per year. Because of this, we today believe that once upon a time moon was way closer, and also Earth was spinning much faster, about 4 times as fast. And because of this, we also believe that one day moon may actually go beyond the ability of Earth to hold it and become its own body, possibly I guess another planet or another dwarf planet orbiting around the sun. But what if the Earth was not spinning as fast and was spinning similar to Mercury and Venus? Well, in this case, the bulge would be actually behind the moon at all times, simply because the moon would be orbiting around faster than the spin of the planet. And this would obviously slow down the object, which is exactly why we believe all of the moons that existed around Mercury and Venus eventually fell back to the surface and most likely, at least for Mercury, created one of these beautiful spots on the surface. Now we obviously don't really know which one it was, but technically if we were to go to Mercury and investigate, we could probably find out by just looking at the impact caused by the collision. But since there are so many different craters to look at, it would be pretty difficult to discover which one it was, even though technically we should really only be looking at the craters on the equator. But could the moon have been much farther away from Mercury? Like, for example, could it be in orbit somewhere like 1,000,000 kilometers away and still be there and we just don't see it? Well, here we come to the other feature we need to talk about, the so-called heliosphere. If we look at the gravitational parameters formed by the Sun and, for example, Earth that's right here, you can kind of see that because Sun has a lot more gravitational potential and it has obviously a lot more mass, it forms this unusual sphere around our planet known as heliosphere, which is the only region around our planet where we can easily hold on to the moons and other objects. Beyond this heliosphere, nothing really can stay in orbit and actually becomes part of the Sun's orbit. This heliosphere around planet Earth is roughly around 1.5 kilometers in radius, which is about 1/5 of the radius of where Moon is currently located. But for planets closer to the Sun, the heliosphere decreases in size. Here are some other objects for comparison, and you can see that for Venus it's about 1,000,000 kilometers, for Mercury it's significantly lower. Which of course means that Mercury cannot really hold on to objects as easily as Earth, simply because the Sun just kind of steals them. And due to this, only close moons are possible around Mercury. But if the moon is too close to Mercury, within only a few 100,000,000 years, and possibly even sooner than that, due to the relation I just described to you, due to the tidal interaction, it basically just falls back to the surface. So as it stands right now, there's really no way for Mercury to have a stable moon for longer than a few million years. It either disappears and becomes part of the Sun, or it becomes the property of the surface of Mercury. And pretty much the same applies to Venus, except here the story is a little bit more interesting because we don't think Venus was always spinning so slow. We think, at least we believe, from I guess the last few years or so, that the reason Venus spins so slow is actually because at some point it had a very unusual ocean on the surface, so-called global ocean, that caused, due to the tidal effects from the Sun, the planet to slowly spin slower and slower. And because of this effect, eventually Venus was spinning really slow, and we don't really know what happened next and what came first, whether the Venus heated up and the ocean disappeared, or whether if it had a moon, the moon started to slowly fall down and eventually caused a collision that then released all of this other stuff, forcing the Venus to become this hellish world where no life can technically survive. All of this is a mystery that we would like to solve, because we would really like to find out if Venus became like this from being an Earth-like object due to the so-called runaway greenhouse effect, or if it was due to a collision from, for example, its own moon. And in order for us to learn all of this, we of course need to launch some sort of a mission that investigates this in a little bit more detail. But at the moment, even if we land on the surface, it's still going to be very difficult to find out, because Venus has an extremely thick atmosphere that sort of erases all of the signs of previous collisions. So unfortunately, some mysteries may remain mysteries for a long time. But in a nutshell, this is why neither Venus nor Mercury have any moons. Although in case of Venus, since it does have a relatively large heliosphere, which is, as I previously showed you, around 1 million kilometers, it could potentially have a moon, a really small moon that's difficult to see, somewhere farther away, like up to about 1 million kilometers. This would be probably some sort of a captured object, and it would be somewhat difficult to find it. But this is of course hypothetical, and we don't really know if there's anything around it right now. Although chances are, if there is something, we're definitely going to discover it sometime in the next decade or so, simply because our telescopes have gotten so much better and so many more amateur astronomers became interested in looking into the night skies and discovering new things. Hello wonderful person, this is Anton, and today we're going to be talking about our beautiful neighbor Venus, the planet that seems to have at least 37 active volcanoes on the surface, something that kind of surprised the scientists. So let's just say you were choosing a new planet to try to colonize and to try to send a new mission to. We have two choices. Either we go to Mars, which is obviously being planned by different space agencies and of course Elon Musk, or we can try something a little bit different. We can try Venus. Now, as you can see, in terms of Earth similarity, Venus is actually a much better and a much more Earth-like contender. Its size and mass are relatively similar, it also has relatively thick atmosphere on the surface already, it has a lot of necessary components that could potentially form Earth-like conditions, but we obviously would have to terraform it using methods and techniques we just don't have yet. But most importantly, unlike Mars, Venus also has at least some areas in its atmosphere at an altitude of just over 50 kilometers, where the conditions are somewhat similar to the atmosphere of Earth. The only difference being that there's no oxygen and there's a little bit more acidic compounds, but we've already speculated that life could technically exist there. Although in every other respect, at least on the surface, the conditions here are, well, comparable to what you would call hell. Extremely hot, extremely pressurized, and very acidic. This is the actual picture taken by the Soviet Venera probes, the probes that were able to survive for only a couple of hours before being completely destroyed by the conditions here. But it seems like the more we learn about Venus, the more we realize that it does seem to be a place where life could potentially exist, and most importantly, this planet does seem to have a lot more activity than we originally speculated. And not just atmospheric conditions, but also conditions on the surface, making Venus a lot more geologically active than we originally believed. And geological activity is, as we know today, extremely important for, well, not just maintenance of the planet, but also the potential existence and maintenance of life on the planet as well. And one of the more important geological activities that we can have on the planet is of course volcanoes and plate tectonics. But unfortunately, we haven't really discovered any plate tectonics on Venus, so we don't really know if there are any, most likely not so far. But in terms of volcanoes, the story is completely different. Although, these are not really the volcanoes you're going to find on Venus. They're a little bit different, actually very different. They seem to be very different from anything we have on planet Earth as well. And the reason we know so is because of the signs we've observed on the surface of Venus, the objects that the scientists currently refer to as corona. Now, these geological corona have only been found on two different objects in the solar system. One of them is Venus, and the other one is the tiny moon known as Miranda that orbits Uranus. Here's what Miranda looks like in comparison to planet Venus and to some extent planet Earth as well. Both Venus and Miranda have these corona, and they seem to be forming in a very similar fashion by the action of the heat from the inside of the planet and a kind of a heat bubble that forms underneath this region here that then lifts up, and as the heat dissipates and also as some of the lava escapes here, it leaves behind these strange corona, some of which are quite gigantic in size. This one, known as the Artemis corona, is about 2,000 miles or about 3,000 kilometers in size, with the actual volcanic activity happening right here at the edges of this corona. And so the scientists behind the paper, you can find it in the description, essentially try to investigate this by simulating how these corona are formed and by trying to analyze if the structures that are visible on Venus and of course on Miranda could be explained as a kind of volcanic activity on the inside of the planet. And because there are so many different corona on Venus, and because these corona don't really have a very good explanation right now, other than of course being created by some kind of volcanic activity, the scientists in this paper were very eager to try to recreate the morphology or the actual visible signs of these corona by using computer simulations. And they of course discovered that it's very likely Venus is still volcanically active, and what we're observing on the surface of Venus can only be created by a recent volcanic activity from these unusual corona formations. And at least on planet Earth, volcanoes mean quite a lot. For example, you might already know that volcanoes recycle a lot of different stuff on our planet, including of course carbon dioxide. So for example, here's one of the things that happen on planet Earth. This is a very simple simulation tool created by the scientists in Colorado University. Here what you're looking at is the new plate that's going to be going under this older continental crust plate, and this layer right here shows you all of the sediment that was deposited over time, including all sorts of minerals that were created by fixating, for example, carbon dioxide or even things like sulfurous and phosphorus. And eventually, as the plates start moving and one goes under the other, within only a few million years, all of this carbon dioxide, as it warms up inside the planet, and of course other chemicals as well, they'll start slowly seeping out, creating the volcanoes on the surface of the planet. This is just one of many ways that volcanoes do form on the planet, and as you can see right here, all of this gas right here gets released into the atmosphere, gets used by different types of life on the planet, and then eventually gets fixated into the different types of sediments that then continue the cycle. So all of this takes a few million years to complete, but this is how a lot of the circulation of the atmosphere happens on the planet, and this is why volcanoes and geological activity on the planet are essential for the survival of life. Obviously, this is a very simple model, a lot of more complex things going on, but this is one of the reasons why discovering volcanoes on Venus is kind of important. It allows us to understand that the planet might be a lot more geologically active than we initially assumed. It also, of course, means that trying to investigate and obviously colonize this planet at some point might be much more beneficial than trying to colonize Mars that doesn't really have much going on the surface or inside of it. Unlike Mars, Venus seems to be quite geologically active and also might be able to, at some point, recycle its atmosphere. And as you can see from this illustration, the scientists have confirmed at least 37 different active or possibly dormant volcanoes that at least to some extent were recently active. Now, interestingly, on the surface of Venus, all of these corona are usually extremely large, at least a few hundred kilometers in size, suggesting that the volcanoes here, at least the ones we've seen so far, seem to be these gigantic formations unlike the ones on planet Earth. On Earth, the volcanoes for the most part are much smaller and also seem to be distributed along the lines of the tectonic plates. So Venusian geology does seem to be at least to some extent different, but this is just some of the ones we've discovered. There could be a lot more hiding underneath the atmosphere. Nevertheless, all of these discoveries, along with the missions that NASA is planning, will definitely make Venus a super exciting world for us to explore in the next decade or so, mostly because the missions being planned here are going to redefine our understanding of this planet. And you never know, at some point we might even find a way to somehow remove all of this toxic and thick atmosphere, and possibly even find ways to somehow slowly terraform Venus back into what it used to be a long time ago. An Earth-like planet. At least we think it used to be like this. And even if it wasn't, it still doesn't hurt for us to try to colonize it and to try to create something beautiful there as well. And one of the major discoveries in this paper is in regards to the differences between these corona that are present on Venusian surface. According to the scientists behind this paper, the differences are actually from the different ages of these corona. In other words, they all seem to progress to the same stages, but they do look very different depending on the age and of course the size of the corona. In other words, all of the newer corona, all of the ones that are still active, will have very similar features that seem to be all present along the edges of these corona, identifying Venus as a geologically active planet. And the other major discovery is that these active corona seem to be also kind of clustered, as if some regions of Venus are still active, the other regions not so much. You can see some of this clustering right here, for example. This of course suggests that maybe there is some sort of a strange geological activity we haven't really learned about yet, and instead of plate tectonics, maybe Venus has something else going on that allows it to exchange the material over time. So honestly, all in all, this is a pretty exciting paper and only gives us one more reason to try to go and investigate Venus in the next few years. Luckily, NASA is definitely planning at least one mission here. The mission that you see right here that NASA will be launching in the next few years, and you can also learn about this in one of the previous videos. But hopefully even more missions will be planned and launched to Venus in the next few decades, because this is definitely one of the more exciting objects in the solar system. And the volcanic activity discovered in this paper is one of many reasons why Venus should be our priority, not really Mars. Hello wonderful person, this is Anton, and in this video we're going to be talking about a discovery of a very unusual asteroid that seems to be one of the closest asteroids to our Sun, and it's also really massive. So in some sense, it could be potentially dangerous to Earth as well. So the asteroid we're looking at right now is actually known as Atira. By definition, all of the Atira asteroids are always orbiting within the orbit of Earth. In other words, they are kind of like the inner belt asteroids. Currently, this is the smallest group of asteroids known to us. There's only about 21 of them that's been discovered so far. But all of them are also really large. As a matter of fact, they're all within about 1 kilometer in size, and in some cases might potentially cross orbits with Earth as well. So in other words, a lot of these asteroids are actually kind of dangerous. And the main reason is not only because they orbit so close to our planet, but because when we're looking for asteroids, it's very easy for us to see asteroids that are away from the Sun, mostly because we're looking at dark space. But all of the asteroids that are orbiting close to the Sun are very difficult for us to detect, because basically the Sun is kind of covering most of them. In other words, in order for us to detect anything in this region, we always have to look at these asteroids during twilight, basically at dawn or at dusk, when the Sun is not too bright, so it allows us to kind of see some of these asteroids in the night skies. And to do this, a lot of specialized telescopes have been developed, and we also rely on a lot of automatic systems. One of such online systems is known as the Virtual Telescope. It's basically a remotely controlled telescope that's controlled via the internet, created by the discoverer of this new asteroid, an Italian researcher by the name of Gianluca Messi. And as you can see from this picture, he got really lucky recently and discovered this asteroid that you see on the screen. This is currently known as 2020 AV2, and 2020 is obviously the year when it was discovered. And what makes this asteroid very unusual compared to all of the previous Atira asteroids is that it seems to be actually within the orbit of Venus. In other words, it seems to always orbit within this circle here, approaching Venus and Mercury once in a while. This also currently makes this asteroid the second closest asteroid to our Sun, slightly beat by the previous discovery from 2019, the asteroid 2019 LF6. But unlike this asteroid, the new discovered asteroid does not have this eccentric orbit. As a matter of fact, from all of the so-called Atira asteroids we've discovered, most of them seem to possess very eccentric orbits, and some of them even have eccentricity that's nearly 97%, making it some of the most eccentric objects in the solar system except for certain comets. Now, a lot of them actually leave really far, almost reaching Jupiter, and then come back close to the Sun. But unlike all of these other eccentric asteroids, what seems to be unusual about the new discovery is that its orbit is a lot more circular than other asteroids. Here, the eccentricity of 2020 AV2 is only about 17%, and it basically kind of goes in between the orbit of Mercury and the orbit of Venus. But the thing is, it also never really approaches either planet really close. The closest distance that it gets to is about 10 million kilometers, which creates a lot of really interesting questions. One of them is, of course, how did it even get here? What caused this asteroid to assume this orbit? And the second question is, of course, well, we think that this is not a stable orbit. So what is going to happen to this asteroid eventually? The current size estimates suggest that this is anywhere from about 1 to maybe 3 kilometers in diameter, making this a relatively large rock. And if you've watched some of the previous videos, you might also remember that in the last year we've discovered at least 3 craters on our planet that were created by rocks that are very similar in size to this. The most recent discovery, coming from the Lao, of a large crater that's about 15 kilometers in diameter was actually created by something similar to this. This, of course, doesn't really give us any comfort because it just means that these rocks are still out there, a lot of them do collide with our planet, and one of them might eventually make its way toward Earth and collide with it as well. Although currently we don't think that it's going to be this specific asteroid. As a matter of fact, it has a much higher chance to collide with Venus right now than it does with planet Earth. But the other major mystery is, of course, in regards to its low eccentricity and the fact that it never actually crosses the orbit of Venus. It never really comes close to orbit of Earth at all. What exactly caused it to have such an unusual orbit? And more importantly, are there other asteroids that are similar to this somewhere else hiding in this region? And this is, of course, a very important question for us to answer because we need to understand how these asteroids form and what makes them assume these orbits. These Atira asteroids, or I guess in some sense you can also call them the twilight asteroids because they can only be visible when it's twilight on Earth, are probably some of the more dangerous asteroids out there. And the two main reasons are, of course, that we can't really see them very easily. They can come from out of nowhere. And the second reason is because they get to approach both Venus and Mercury much more frequently. A single year here only takes about 150 days, meaning that every 150 days this asteroid has a chance to slightly shift its orbit, and then that orbit can accidentally cross with any of the planets in the solar system. And since we've already found 3 different craters on the planet that were created by similar asteroids within the last 3 million years or so, this kind of makes it really important for us to understand. Could these craters have been created by these unusual Atira asteroids? And obviously if the material here matches to the one on the planet Earth, then it's very likely that these are the main culprits behind all of the collisions. Maybe these asteroids are the ones we should be actually watching more carefully. So all of this is really important for us to understand in order to basically protect our own civilization. On the other hand, we also would like to find out how many of these asteroids are located in these regions. It's very unlikely that we're going to discover something similar to an asteroid belt with hundreds of thousands different asteroids, but nevertheless there could be a lot of rocks hiding in this region, many of which could potentially be dangerous to planet Earth as well. But one of the more immediate mysteries is, of course, in regards to its unusual orbit. It's the only asteroid that has such an unusual low eccentricity orbit that doesn't really come to any major planet, which means that we need to study this in a little bit more detail. The only current explanation for how it got its orbit is by possibly passing next to some sort of a planet, possibly even Jupiter, which took it closer to the Sun, and then through the action of the so-called Kozai mechanism, which I explained about 4 years ago in the video that you can find somewhere above my head right now, the orbit of this asteroid eventually shifted, making it look the way that it does today. But I guess the scary part here is that Kozai mechanism never stops acting. As a matter of fact, it's very likely going to shift the orbit again with time, suggesting that at some point the asteroid will either get a much closer orbit to the Sun, or it might actually increase its eccentricity once again and start crossing planet Earth's orbit, which is something we don't really want asteroids to do. And I guess if we're lucky enough, this asteroid will one day hit another planet, but at this point it's probably going to be either Mercury or Venus. It's currently not really estimated to hit anything, but if the Kozai mechanism shifts the orbit of this asteroid enough, it will definitely cross the path with one of the planets, creating a relatively large collision, which we could then of course use to study what happens when these asteroids collide with planets like Earth. Hopefully by not actually having it collide with Earth, of course. Currently, our understanding of the effects of asteroids on planets is actually not really that advanced. We know they do something to the climate, for example, we're just not entirely sure what. And we know many collisions have happened in the past. So by using other planets as a kind of an experimental box or experimental lab, we'll definitely be able to understand the effects of asteroid collisions and of course learn to prevent them in the future as well. Hello wonderful person, this is Anton, and in this video we're going to be tackling a mystery of our solar system. Specifically, why is it that the planets in our solar system have such different compositions? Now when you look at various planets in our solar system, you may quickly realize how different they look, but what you may not realize is how different the insides of those planets are as well. Even the terrestrial planets, Mercury, Venus, Earth, and Mars, are very different from each other in what's on the inside. For example, Mercury has a lot of iron. Venus, on the other hand, has a lot less iron in comparison to its silicates. Mars is really small and also has very low density, and Earth seems to have the tremendously large amount of mass and also density compared to all three other objects. Same can be said of Jupiter and Saturn, but the idea here is that the composition of the planets is very different. Now this was not really well understood, but a recent study from University of Copenhagen actually tries to tackle this using, well, geology. They looked at various meteorites found across our planet that came from various objects, such as, for example, Mars, and also even from the asteroid belt. Several asteroids were collected from an asteroid known as Vesta, and they studied the calcium isotope composition of several meteorites called anhydrites and urielites. And what they discovered is that the ratio of isotopes in samples correlated directly with the masses of their parent planets and asteroids. Or in other words, what they discovered was that a lot of planets stopped growing at different times. The protoplanets all grew at the same rate, basically they all increased in mass relatively identically, but some of them stopped growing earlier, such as for example Mars and Mercury, others grew much longer, such as Earth. But why is it that their composition is different? Well, this actually suggests that our solar system received more material from the outside, most likely from nearby supernova, as the time went by. So by the time Mercury finished growing, more material may have come to our solar system but was actually absorbed by Earth. And similarly, a lot of material was absorbed by larger planets like Jupiter and Saturn. In other words, a smaller planet most likely ceased growing early on, probably indicating that this was one of the oldest planets in the solar system, while larger planets grew much longer and thus are most likely the youngest planet in our solar system, which makes Earth the youngest terrestrial planet. So just to summarize, what have we learned from this particular study? Well, it seems that our solar system was actually developing throughout possibly several millions or even hundreds of millions of years, and throughout that time it actually received more and more material from the outside, more likely from the supernova, but possibly also just from the gas nearby. As this gas arrived to our solar system, various planets started absorbing it, but those planets that were smaller or that kind of finished accreting their mass have actually received almost nothing. The newer gas and newer materials most likely ended up in planets that are most massive today. This also means that a lot of this material that came later on was actually very different from material that was there in the beginning, and this would explain why planets are so different in their composition. So this study is actually very unusual and very interesting in that it presents the growth of solar system as this dynamic and very long process where planets were still growing even millions of years after some of the planets already stopped growing. This is very interesting and definitely requires more follow-up studies. For now though, that's all I wanted to mention in this video, and hopefully now you know why the planets in our solar system are somewhat different in composition. Hello wonderful person, this is Anton, and in today's video we're going to be talking about Venus and its surface. We're going to discover why the surface of Venus has such an unusual amount of volcanoes and why it is actually so hot. So there's a lot of papers out there trying to speculate about why Venus is so much hotter than Earth, even though it's pretty much identical in every other parameter. The temperature here currently is 472 degrees Celsius, or about 745 degrees Kelvin, which is pretty much like 450 degrees higher than it is on Earth.
And yes, it is closer to the sun than Earth, but not by amount that should cause such a tremendous temperature. Now we know that the temperature is very likely caused by the tremendous greenhouse effect from the atmosphere that's about 92 times thicker than the atmosphere on Earth, and also the composition of the atmosphere that's pretty much mostly carbon dioxide. So in other words, most of the temperature comes from a tremendous greenhouse effect. But that's not really what we're going to be discussing today. We're going to be discussing the reasons for such a hot and unusual atmosphere, and also for the differences in geology and geological activities on Venus. Now, if we remove the atmosphere, because it's actually very thick and hard to see through, and also remove the clouds because we don't really need them, you'll notice that the surface of Venus looks like a planet that is basically made up of a lot of volcanoes. There's a lot of volcanic activity signs everywhere, including right here is a large one with very unusual leg-like formations, which are actually unique to Venus. And there's a lot of other volcanoes, like there's one right here, there's a bunch right there, and overall, if you actually count all of them, you'll find that there's something like 1,600 major volcanoes on Venus. As a matter of fact, Venus has the most volcanoes in our solar system, more even than Io. And Io, if you remember, is the most volcanically active object in our solar system, and that's the moon of Jupiter. That's right here. So Io does have a lot of active volcanoes, but when it comes to inactive or old volcanoes, Venus basically takes that prize. So in terms of just a number of various volcanoes, including the large volcanoes, this is definitely the place to take all of those prizes. Now, on Earth, we have at least one major volcano, and that's in Hawaii. On Venus, there is almost 100 of similar-sized volcanoes. And considering the fact that its surface is very similar to Earth. It's about 90% basalt rock. It's very unusual to see that about 65% of the entire planet here consists of various lava plains, indicating that volcanism played a very major role in changing how this planet looks. Now, we've actually kind of measured the age of all of these volcanoes, and they all seem to be about 500 million years old. And that's very unusual. And for the most part, none of them are actually presently active, or at least we haven't really seen any indications that any of them are active. But we have seen parameters in the atmosphere that indicate that some volcanoes still kind of spew things out, specifically sudden increase in methane in the atmosphere indicate that there is at least a few volcanoes that are still spewing things out. But for the most part, this is essentially what the surface looks like. A lot of just dead volcanic activity. Or in other words, dormant and sleeping volcanoes that are now completely inactive. But a lot of recent studies have actually showed two very important things about volcanoes on this beautiful planet. One is that, well, they actually are responsible for changing the crust of this planet every few 100 million years completely. So in other words, Venus is actually going to have a major volcanic eruption activity sometime in the next few 10 to maybe 100 million years, or maybe a little bit longer. We don't really know exactly how long it will take, but when the crust here heats up even more, when it gets even hotter, it's going to be weak enough to support the pressures coming from the inside, and the new volcanic eruption will begin. And we're going to simulate this by basically colliding a few asteroids just to kind of emulate what's going to happen to the surface of Venus. And so essentially, here we go. So here are the volcanic eruptions that will start at some point and will continue for about 100 million years. Now, there's going to be a lot more, obviously, but this is just an initial eruption event. And so essentially, Venus will, you could call it, burst from the inside, and a lot of the heat and a lot of the pressure will start coming out and recycle the entire surface of the planet once again. So there will be so many eruptions that the entire surface will change and become renewed yet again. And this will happen quite a few times in the next 5 or 6 billion years until our sun expands and swallows Venus. But this is essentially how Venus recycles its surface. And so up to about 2,000 more volcanoes will be formed, and all of them will essentially create a completely new surface here. Now, on Earth, it doesn't happen that way. On Earth, we have something called plate tectonics, which actively recycles our surface and actively dissipates the heat from the inside, and basically makes our planet not only habitable to life for many, many reasons, but also recycles the very, very important CO2, carbon dioxide. Because of the plate tectonics, because of the way that the actual plates move around, a lot of the CO2 gets trapped on the inside and then gets released with the volcanoes and gets trapped again. On Venus, this doesn't happen. Because the eruptions happen so suddenly, the entire CO2 gets released right away. And so one of the reasons Venus is the way it is today is because it actually lacks plate tectonics. Now let's go back a few billion years and find out why exactly is it that Venus doesn't have any plate tectonics on the surface. We're going to create a new system here with the Sun and two planets. One is going to be right here and one is going to be right here. So these are early Venus and early Earth. So both of these are relatively similar in pretty much everything. As a matter of fact, they were very likely twins. They both had very similar surfaces, very similar densities, and they even had water on the surface. So here is the face of early Earth with basically crust and water and atmospheric pressure of about 1 atmosphere. This is just for the simulation purposes. And here's Venus. Very similar in every respect. Maybe a little bit more water here, but this is just because I pressed this button a little bit too long. We're gonna maybe decrease a little bit of water, making it a little bit more realistic. And so here we go. Now, with time, Venus started to lose the water. So something happened and the water started to evaporate. It's probably because there wasn't enough magnetic magnetic field to protect water. And it's also probably because it was a little bit closer to the Sun than the Earth. But basically, water started to disappear completely. And we're still not entirely sure how, but water is directly responsible for keeping very active plate tectonics. So for example, on our planet Earth, because of water, the actual plates underneath the water are different from the plates above it. And they're a little bit more dense, and so they actually sink underneath these other plates. And this sinking allows for the recycling of various crusts that are deposited on the surface, and obviously recycles carbon dioxide as well. Now Venus lost the water, and its crust became sort of very similar everywhere. It sort of started, it became very uniform. It also started losing atmosphere at first, because there was nothing protecting it from the Sun, but we're not going to remove atmosphere because Venus recovered from that event later. Now at this point there was no more water, and so all of the surface was kind of similar. And it started to heat up relatively similarly as well, but because it was closer to the Sun and because it was actually a little bit hotter than the Earth, it kind of repaired itself. So basically it was able to recirculate the materials relatively actively, so no plates were actually formed. And this is a very interesting concept because on Earth something else happened. Let me just show you what happened on Earth. So first of all, water always stayed with us. But also another really important difference, or another important event started happening here on Earth. Some of the areas where the crusts were kind of joined together were actually still damaged from all of the heat and were not repaired just enough, mostly because they were cooling down too fast. So even though for the most part, all of these planes on Earth, basically all of the plates were, just like on Venus, being repaired actively because of the heat, some areas, so areas where later on we developed the so-called plate tectonics, plate crusts, or I guess boundary areas, as you can also call them, were actually constantly damaged. They never had a chance to repair. And at some point, they basically snapped and created the boundaries that we have today, where the plate tectonics either converge or diverge or slide against each other. And all of this was very, very important and only happened because Earth was a little bit farther away from the Sun and it was a little bit cooler, and also because water was partially responsible for causing this damage. We're still not entirely sure how all of this occurred, but basically Earth maintained its plate tectonics and Venus didn't. And because Venus didn't have the plate tectonics, it started to warm up. It started to heat up more and more and more. And water by then was probably already gone. Atmosphere was already dwindling. And then a few 10 or maybe a few 100 million years later, something started happening. The planet was so hot, it became so heated that it suddenly started exploding from the inside. And we're going to simulate this by basically colliding a bunch of objects into Venus to create this humongous explosion. Now, it wasn't really as big as you're about to see, but this is just to kind of give you a dramatization of such event. So the volcanoes basically started erupting all over the surface. This was the first such eruption. There were probably a few more afterwards. And the entire surface became essentially molten, became covered with these very, very large volcanoes. And all of the carbon dioxide on the inside got released. A lot of other stuff like sulfur dioxide became released as well. And suddenly the atmosphere of Venus became really, really thick. So because of this sudden increase in atmospheric pressure, the atmosphere of Venus was now something like 90 times the atmosphere of Earth, and it acquired a tremendous greenhouse effect, and since then, Venus was really, really, really hot. And it very likely changed a little bit throughout the years with more eruptions, but for the most part, that's essentially how Venus recycles its crust and what actually happens on the surface and why it's actually so hot. Now, it's very possible that this might one day happen to Earth as well, especially if we lose the water. But for now, we're pretty safe because water does protect us and does create and maintains the plate tectonics on our surface. So for as long as we have plate tectonics, we really shouldn't have such a crazy and dramatic runaway greenhouse effect. And as you can see, this is the new surface of Venus after the collisions. Now, this planet will very likely undergo another such event in the next few 100 million years, so we might one day even witness it if we're still around. But for now, though, what we know about Venus is that even though it started like Earth, because of the greenhouse effect and because of the lack of plate tectonics on the surface and lack of exchange of material on the surface, it's basically a very, very hot, hell-like conditions.
Hello wonderful person, this is Anton, and in this video we're going to be talking about our beautiful neighbor Venus. This is what it kind of looks like in Space Engine, and it sort of represents what it really looks like in real life as well. Today we'll talk about the discovery coming from Venus that suggests that Venus has really interesting climate and also climatic changes that we really didn't know existed. So this beautiful terrestrial planet is actually the closest planet to us, not Mars. At its closest, Venus approaches Earth at a distance of about 38 million kilometers, which is relatively close when it comes to planetary distances. But today our interest in Venus is in regards to its past, specifically in regards to its changes related to the so-called greenhouse effect. We believe that Venus has undergone a dramatic change in its past, going from, well, basically something that looked more like Earth with liquid water on the surface to a tremendously hot, hellish conditions with very inhospitable surface, equivalent to, I guess, what you would literally call hell. Temperatures here are close to 500 degrees Celsius, the pressures are ridiculous, the atmosphere is also full of acidic elements, and so most of the probes that were sent here didn't really survive for very long. The only pictures of the surface that we do have all came from the Soviet missions back in the 70s. The so-called Venera missions were able to survive on the surface for just enough time to take a few shots and were then most likely completely destroyed by the super high pressure and, of course, the temperature. And although the photos that we have are not super detailed, they do give you an idea of what it's like on the surface. Now, if you'd like to explore these photos, I'm posting the link for this website that was created by Don Mitchell quite a while ago, over a decade ago actually, and he does have these really well reconstructed photos from the Soviet mission. But even though one day we would like to go back to Venus and possibly take a few more shots of the surface, it's really the atmosphere of Venus that's the most interesting part to us right now. And more specifically, this composite shot right here, taken by the Japanese Akatsuki mission, gives you an idea that there's something happening in the atmosphere of Venus that we can't really explain just yet. There are these dark patches pretty much everywhere. And these dark patches are not really simply just clouds or any other formations that are easy to explain. They do have properties that we've only observed in some features on Earth. Specifically, they seem to actually change the ultraviolet absorption of the planet. In other words, some of these dark patches in the atmosphere of Venus, as they travel around the atmosphere, they either increase or decrease the UV light absorption. And this does influence the atmosphere quite a lot. Now, one thing you need to know about Venus, and here's maybe a slightly better view of this, you can't really see its surface. Pretty much about 90% of all of the light that comes to Venus is reflected. It has a very high albedo, and the word albedo refers to the reflectivity of an object. So obviously things like mirrors, for example, have very high albedo, whereas things like black roads will have very low albedo. And the albedo of Venus is so high that if we were to make it similar to albedo of Earth, the temperature on the planet would jump dramatically. So right now the temperature is shown at 475 degrees Celsius, and just for fun, let's actually decrease the albedo to what it is on Earth, which is roughly around 35%. And look what happens to the actual planet. It becomes a lava world. It literally lights up, it melts, everything becomes ridiculously hot. And so the atmosphere itself, even though the planet is already super hot, and even though the greenhouse effect influenced the temperature on the surface, still kind of protects the rest of Venus from becoming a completely molten world. So this is why, for us, it's interesting to find out what's really happening in the atmosphere. And since 2007, we've been actively studying the atmosphere and discovered that the reflectivity of this planet is correlated with the number of these unusual dark patches. And we're still not really sure what they are. The scientists currently refer to them as unknown absorbers. And the explanation differs from them being some sort of particles, some sort of aerosols, possibly something related to oxides of sulfur, or maybe some kind of a ferric chloride, or essentially something that can influence the absorption of ultraviolet light. But late Carl Sagan even suggested that there are some similarities to bacteria living in the atmosphere of our own planet that seem to actually have very similar features. In other words, he even suggested that this could be signs of life in Venusian atmosphere, simply because of the properties we're observing. But what is really unusual is that as these patches were changing, so was the absorption of the ultraviolet light. As a matter of fact, since 2007, the absorption of UV light on Venus halved. But then it started going up again. And so that's exactly what this recent paper talks about. What they did is analyze the data from these different missions and discovered that the changes in the dark patches in the Venusian atmosphere were correlated with the changes or actually heating of the atmospheric layers, and thus most likely the increase of the wind speed. And the winds on Venus are already really fast. The speeds here can reach up to about 300 kilometers per hour. And this is due to a phenomenon known as superrotation, where even though the planet doesn't spin, the winds above it rotate, or technically move, really fast. And today, or at least now, because of this paper, we believe that all of this is related. So these patches, wherever they are, whatever is in them, are causing the planet to drop its albedo and then absorb more light, specifically UV light from the sun, which heats up the atmosphere, accelerates the winds, and creates, I guess in a sense, summer. So technically the conditions in Venusian atmosphere change very periodically. And according to the observations from this paper, these changes happen roughly around every decade, or around 12 years or so. And so this suggests to us that Venus has these climatic changes every 12 years, which we have never known existed and which we couldn't really explain before. But this of course creates a lot more questions than answers. And it's of course interesting that these dark patches relate to all of this, but what are the patches? What are they made out of? And this of course means that we need to go to Venus, we need to find a way to explore the atmosphere of Venus, and potentially find a way to launch some sort of an atmospheric probe that can study this in a little bit more detail and maybe discover if it's life or not. And this is really the important part, because if it is life living in those atmospheric layers on Venus, this would mean that life can survive much more inhospitable environments than we imagined. So here, even though the surface is ridiculously hot and extremely difficult to survive for anything really, the atmosphere, however, might have something for us to look into. And specifically, there are layers in Venusian atmosphere where the atmosphere itself and also the temperature is somewhat similar to what we have right here on Earth. Although not entirely chemically similar to what we have on Earth, because there are also things like acids and of course a lot of CO2 and absolutely no oxygen in those layers. Nevertheless, they could create conditions for atmospheric or aerial life. But what's even more unusual about this particular discovery is that the variation in climate that we've observed on Venus seem to be dramatically stronger than they are on Earth. In other words, not only does Venus have an extremely powerful greenhouse effect, it also seems to have very powerful climatic changes, with temperatures very likely changing by a huge amount. Every single, I guess you could call it winter, even though it's still hot, it's maybe not as hot as every summer. And this is of course not including things like storms, or I guess the gushes of wind that are present in the upper atmosphere of the planet that are already really strong, stronger than pretty much anything we have on Earth. But what I find really intriguing in this discovery is the importance of albedo. Just to show you again, remember the albedo value for Venus is basically the highest of all planets in the solar system. It's at 90%. And this study really underlines how essential albedo studies are to discovery of new planets that are potentially habitable, to also analyzing atmospheres and analyzing atmospheric conditions. Because here, as soon as I change albedo by about 10%, the temperature of the planet changes so much that a lot of the atmosphere disappears and you can actually peer through the atmosphere. And this shows you the power of this property that's very rarely talked about. So here the temperature jumped by about 100 degrees when I changed the albedo by only 10%. So the reflectivity of objects is an important study. This is how we usually study the properties of objects that are far away. But it's even more important to study around objects like Venus, because obviously here, since 90% of light is reflected, even a tiny deviation from that makes the planet dramatically hotter. And since we're not entirely sure what really caused all of this and what's causing the changes in these unusual particles, or basically reflectivity of the planet, trying to identify the source is very important. There are suggestions that maybe it's because of the cosmic rays, maybe the actual cosmic radiation or the activity of the sun itself causes the changes in reflectivity of Venus. In that case, well, it's a lot easier to understand and a lot easier to simulate. But right now, the changes we've detected are not really connected to the so-called solar cycle. By the way, you can check out a video about solar cycles right there above my head. It's a very recent study that analyzed them in more detail. But either way, a very exciting study, and hopefully this will help us launch a mission to Venus soon so we can explore this planet a little bit more. Unfortunately, there hasn't been a lot of talk about Venus, and there really haven't been that many missions to Venus. The major missions all happened back in the 70s when the Soviets went there, but since then no one really came. But still, studying what happened to this planet and also understanding its climate is super important so we can actually prevent this on Earth. We don't want Earth to turn like this, and we know Venus used to be very Earth-like before. So let's hope we can learn some lessons from Venus so we can preserve our planet as it is right now. Hello wonderful person, this is Anton, and today we're talking about Venus. Now Venus is not a planet we normally talk a lot about, mostly because whenever we found out that it was relatively hot and somewhat hellish there, we kind of lost interest in trying to colonize it. Even though technically it should be the most interesting object to us because it's a lot closer in mass and even in composition to Earth than Mars is. But still, it's just too hot and we don't really know how to get rid of that heat. This is what we believe Venus may have looked like billions of years ago when it very likely had ocean. We'd still believe that Venus was very Earth-like in the beginning, and we believe it probably looked something like this. Mostly because of the fact that it's extremely similar to Earth in density. It has water that we've detected escaping from within. We also detected a lot of CO2, obviously, and a lot of the similarities resemble our planet Earth, but as if basically it transitioned from a relatively habitable world to a world filled with CO2 that's completely uncontrolled, creating a tremendously large greenhouse effect. Now, today we're talking about a study that analyzed this idea of Venus having water, and when they ran the simulations using tidal inversion software from the Oregon State University that's often used to try to calculate the amount of tides and also the energy produced by tides. It's actually a very complex software that's used pretty regularly by people studying the oceans here on Earth. They realized that, well, if Venus had oceans, and if Venus had a certain depth of an ocean, there's a very high chance that it would most likely cause Venus to lose those oceans and become what it is today. This paper that you can find in the description below is an analysis of various tidal effects that Venus would have experienced if it had a liquid ocean of various types of depths based on the topography of Venus that was then used to calculate what kind of a shape the ocean of Venus would have. And the results were quite interesting. Now, these are not necessarily conclusive results, but based on the simulation and based on the topography, what the scientists discovered is that within only a few million years, Venus, or at least the surface of Venus, would probably look like this. In other words, because of the effects that it gets from the sun, because of these tidal effects, it's very likely it would transform into what it is today relatively quickly. Now let's discuss this in a little bit more detail because it's actually kind of interesting. So first of all, we know that on our own planet, which is by the way this, except that I'm basically upside down here, the tidal effects we get for the most part are coming from both the sun and the moon. And the moon is actually responsible for over 2 times more tidal effects than the sun is. Mostly because Earth is farther away from the sun than Venus. But on Venus, it receives about 2.67 times more tidal effects from the sun than Earth. So here the tidal effects would be quite more dramatic, but at the same time only a little bit more dramatic than the effects from the moon. At the same time, just having a dry surface like this is not enough to have any tidal effects. However, today we know that it's very likely that the surface of Venus is covered with so much thick layers of CO2 that underneath all of this CO2 that we have here, there is a layer that acts as a kind of a supercritical gas. In other words, it's a gas that sort of acts like a liquid and is responsible for changing the rotation of the planet. But we're not entirely sure if this gas was always there. It's assumed today that it was not always like this. On our planet, and I guess pretty much on every planet that has liquid water, the tidal effects are usually caused by the water, which of course makes sense because when we say tides, we often refer to the level of water. But the water itself causes other things. And when it comes to tides, this is normally how it's interpreted. So the gravitational effects from the moon create this kind of a tidal bulge right here on 2 sides of the planet. And that's because the gravity sort of stretches the planet, creating a slightly taller or slightly higher level of water here than here. But the thing is, because the planet also rotates, the tidal bulge actually gets moved a little bit in front of Earth. And so the real bulge is under an angle. And because of this, the effect here is that, first of all, this transfers some of the energy to the moon's orbit and pushes it away from us. So moon is constantly moving farther and farther away. It used to be a lot closer to us, now it's farther, and will be a lot farther in the next few billion years. But at the same time, this force also pulls back on our own planet, slowing it down a little bit. And so today we know that the planet used to orbit a lot faster. As a matter of fact, when the dinosaurs were walking Earth, the single day on Earth was approximately 20 hours long. And when Moon and Earth were just created, a single day was about 6 hours long. So the planet used to spin about 4 times faster. And eventually, every object that has tides becomes tidally locked. So sort of like if we were to look at Pluto and its partner Charon right here, these are tidally locked objects. What this means is that they're always facing each other with the same side. So as Pluto and Charon orbit around one another, they're always facing each other. And this happens because eventually, because of tides, things become tidally locked. This is true for every major object that has any kind of a liquid ocean on the surface or underneath. So for example, every major moon like Ganymede, Io, Europa and so on, all of them are tidally locked as well. And it's very likely that this tidal lock occurred because they have liquid oceans inside. And so pretty much every single object with liquid water or with an ocean on the surface is going to at some point become tidally locked or at least slow its rotation. So this is very likely what happened to Venus. Because this particular study, when they assumed that there was ocean here, which let's just create this really quickly by giving Venus a liquid ocean right here. So in this case, depending on the depth of the ocean, it would most likely cause different types of energy from tidal forces. And when they ran the simulations, they found very different results, but some of those results were quite dramatic. So even though today, if you were to basically add oceans to Venus, because of its slow rotation, the tidal effects would be about 0.15 gigawatt of energy in total, which is something like 5,000 or 6,000 times less than what it is on Earth. If Venus was rotating faster, so maybe something closer to planet Earth, where a single day takes a single day, in that particular case, the energy from the tides would be dramatically higher. And they've discovered that some of those tides might have been just as high as they are on Earth. So in other words, it would produce approximately 600 gigawatts of energy, which, when they ran the simulation, gave the planet so much drag because of the tidal effects that it would start slowing down quite a lot. Some of their calculations suggested that it could lose as much as 72 days per million years. In other words, within about 10 million years, it could have slowed down to a crawl that it has today and basically become tidally locked. Now, those were some of the more extreme versions with a very specific depth of an ocean. I think it was about 600 meters on average. But if the oceans were deeper or more shallow, it may have not had as much effect. But it doesn't change the fact that the tidal effect would still be powerful enough to slow down the planet within about a billion years. And if this planet suddenly slowed down like it did right here, it would then be basically exposed to the solar radiation 24/7. And if it becomes tidally locked like this, it's very likely that it's going to lose any kind of magnetosphere it might have here. Because we believe magnetosphere is actually created by the rotation of the planet, or at least partially created by that, lack of rotation here would kill magnetosphere. Without magnetosphere, all of this ocean would start evaporating like crazy. Venus would most likely start losing tremendous amounts of water really quickly. It would escape into the atmosphere as hydrogen and oxygen, which we still detect even today, eventually becoming barren like this. And then this would start the cycle of CO2 release, and the planet would become hotter and hotter pretty much every single year, with CO2 eventually covering the entire surface, causing really high greenhouse effects and superheating the planet to the temperature that it has today. And so this is one of the major discoveries in this particular paper that suggests that if Venus had ocean in the beginning, this ocean would most likely kill the existence of water on the planet. In other words, it's kind of like doomed if you do, doomed if you don't. If Venus had water, it would most likely lose all of it almost instantly. And if it didn't have water, then it had this really thick atmosphere that probably did the same. Now, interestingly, today, Venus doesn't really have a tidal lock anymore. As a matter of fact, it has something called retrograde rotation. In other words, it actually spins in the opposite direction of other planets. And we believe this is formed by this thick atmosphere. So the atmosphere that it currently has, if you were to look underneath it, and by the way, you'd probably see something that looks like this. But what you would see here and what you would actually feel here would feel like liquid. Because this lower level of atmosphere here has so much pressure and so much temperature that the carbon dioxide that's here starts acting like liquid. It literally flows across the surface of Venus. And this flow also creates tides as well. So there's a very unusual, very interesting CO2 tide on the surface that's causing Venusian rotation to change again. And in the last few billion years, it acquired a kind of a balance where it literally has an equilibrium between the tidal lock caused initially by the sun itself and by the water that may have existed here, and the atmospheric tides that are caused by the heating of the atmosphere by the sun and by the very unusual properties of supercritical carbon dioxide that's on the surface of Venus. And we've recently actually become quite interested in the so-called supercritical CO2 because it also might be the source of very clean energy. But I'm going to talk about this in another video. Nevertheless, the main discovery in this paper is that no matter what Venus used to have in the beginning here, it most likely, even if it was a much faster planet, which it probably was, it would have lost the spin despite anything. It would have lost it if it had thick atmosphere. It would have also lost it if it had the liquid ocean because of the tidal effects from the sun and because it's relatively close to the sun compared to planet Earth. Even though Venus was probably habitable like you see on the screen right here, eventually this actually destroyed the ocean itself. So it's kind of ironic in a sense that these tidal effects basically caused the planet to lose the ocean. What's important about this study is that it allows us to now understand how this could happen on other planets, specifically exoplanets. Because of the approach that this particular paper took, we now can potentially study what happened on other planets. Like, for example, if we go to TRAPPIST-1 with its 7 terrestrial worlds, today we believe that many of these worlds are maybe water worlds. But if they are water worlds, it's very likely that many of them also became tidally locked, and it's very likely that they may have suffered the same fate as Venus. So it's possible that pretty much every world that becomes tidally locked becomes similar to Venus. So this is something that we need to investigate a little bit more, because one day it will hopefully help us find a planet that's not like Venus, not like Mars, but a planet that's like Earth. If we understand how these effects evolve and how all of this changes with time, we'll be able to find this beautiful Earth 2.0. But remember, until that happens, we still only have one Earth. Only this Earth. I guess you can call it Earth 1.0. So we do have to take care of this planet a little bit better than we do right now. Because unless we find somewhere else to live, there is just no other hope for us. Hello wonderful person, this is Anton, and in this video we're going to be talking about a discovery right here in our own solar system. Actually, 2 discoveries. Now, I actually left for a couple of weeks, I had to do a few things, and as soon as I left, we started discovering incredible things in our own solar system, in other star systems, and there's going to be a lot of videos in the next few weeks to basically catch up with all of these events. But this one here kind of takes the cake, because it's basically something that was always there, but we never really noticed it. And as you can see from the picture right here, what we discovered is basically rings. Really beautiful, really awesome looking rings that are in the orbit of Venus and also in the orbit of Mercury. Now these are actually 2 completely separate studies, but it just so happens that they happened around the same time. And interestingly, what these rings suggest to us is that there's a lot of asteroids in the orbit of Venus and Mercury that we've never really discovered, or actually never even looked for. So let's talk a little bit more about this, and let's discuss what was really discovered. So, first of all, this is the first paper that talks about the circumsolar dust ring near Mercury's orbit by Guillermo Stenborg, and the second paper is by Petr Pokorny and Mark Kuchner, and this is the one about Venus, or specifically the ring around Venus. Now both of these papers are in the description below, so you can read more about the study itself, but let me actually explain to you how this was basically discovered, how we were able to identify these particular rings. And to discover one of these rings, the scientists used this satellite right here known as Stereo Ahead. There's actually 2 parallel satellites, one is called Ahead and one is called Behind, and if you were to look at where they're located, They're located in the same orbit as our planet Earth, and this is actually the orbit here, except that one of them orbits a little bit ahead of Earth and one of them orbits behind Earth. And they're used for various studies, but in this particular case, both of these satellites, or specifically this one actually, were just looking at the sun. And while looking at the sun, they were able to detect something really unusual, specifically dust. They were actually able to see an increase of about 5% of brightness due to dust, or basically reflections from the dust, no matter where the spacecraft was in its orbit. And interestingly, this only has one explanation, that there's dust pretty much all across the orbit of Venus and also all across the orbit of Mercury. Now, the dust right here, this is the Venus dust, is actually a little bit more well studied. We even know that the thickness here is approximately 15 million kilometers. But the dust ring of Mercury, even though it's kind of smaller, is a little bit more interesting and a little bit more exciting because we never expected to find anything so close to the Sun. Mostly because we thought that because Mercury is so close to the Sun, the solar emissions, and specifically the solar wind, would actually most likely dislodge anything that would be that close to it. And the only way for this ring to actually maintain itself is to have a source of dust. And this is where it gets a little bit interesting. If we were to try to create this ring in Universe Sandbox just to simulate what all of this looks like, if Mercury is right here, then somewhere in its orbit there are at least several hundred relatively large asteroids, and these asteroids are most likely responsible for creating all of this dust. Now, we're not entirely sure how big these asteroids are, but just based on the amount of dust we've detected, it may suggest that if we were to combine all of this dust into one single piece, it would create a rock approximately 3, maybe 4 kilometers in diameter. And all of these rocks are obviously responsible for shedding all of this dust and then depositing it in orbit. And as the Sun expels some of these dust particles through various activities such as, for example, solar flares or just solar wind in general, each of these asteroids is then responsible for slowly shedding this dust and creating the ring that we've detected. Now, we don't really know the mechanism exactly just yet. We don't even know what's causing these particles to kind of appear as a dust ring. We just know that it's there. And even though we suspected the one around Venus to be relatively large and we kind of knew that it was there, we really didn't expect Mercury to have anything similar. So now we know that pretty much every major object in the solar system has these unusual rings. We're pretty sure that Earth has it as well. We just haven't really been able to detect it just yet because it is relatively difficult to see it. And so basically the discovery kind of looks like this. There is the ring around Mercury that's a little bit smaller, and the ring around Venus, Venus is somewhere right there, that's a little bit larger. And this also implies that it's very likely that Venus has slightly more asteroids, or potentially that Sun doesn't really have as much influence over the region where Venus is located, as opposed to the region where Mercury is. Now, we don't really know much else. Like, for example, we don't really know how long this ring will exist, or if it's going to expand or shrink. And also, we don't really know its composition just yet. We just know that it's kind of thin, and for the most part, the only actual explanation so far is the simulation that was run using, well, actually something similar to Universe Sandbox. Basically, the way that the scientists were able to explain how these rings were formed is by running a simulation for about, well, kind of 4.5 billion years really, and they initially placed approximately 10,000 rocks in the same orbit as Venus. And their simulation showed that even after 4.5 billion years, at least 800 asteroids are still going to stay in the orbit here. And they're still going to orbit and release the actual dust material. And this dust material will then kind of stay around until Sun expels it somewhere to the outskirts of the outer solar system. And even though we don't really know what it's made out of, it's very likely that it's probably rocky and also metallic in its composition. So in other words, it's very likely not ices, not water, not anything that's easy to dislodge by the Sun. It's probably something heavy, and for all we know, it might be even precious. But because this is so diffuse, it's actually very, very thin. It's almost like a vacuum here. These particles are really, really far away from each other. In that sense, it's not really that useful other than scientific curiosity. Like, there's no way we're going to be able to collect these particles or to in any way use them. It's just going to stay in this orbit until the sun expels it for good. And even a spacecraft that passes through this dust cloud doesn't really have to worry about any collisions or anything, because these particles are really far away, really, really small, and it would be really, really challenging for us to even find one of these particles. So in that sense, it's a really interesting discovery, but doesn't have much practical use just yet. It will, however, help us understand our own solar system and the evolution of the solar system, but also help us understand what we're looking at when we're seeing these rings in other star systems as well. And on that note, that's unfortunately all we know right now. As new studies come out, I'm going to definitely mention the follow-up in one of the future videos. But for now, well, that's really it. We discovered two really cool rings in our own solar system around Mercury and Venus. Hello wonderful person, this is Anton, and in this video we're going to be talking about this beautiful neighbor of ours, Venus. In this video we're going to discuss some of the recent research that suggests that we may have been actually wrong about the surface of Venus. We've always thought that the surface here was relatively dead. In other words, there's no volcanoes, there's just a lot of heat, a lot of pressure, and a lot of gases. For the most part, Venus has always been imagined as a kind of a deadly future of Earth. In other words, this is what happens when plate tectonics no longer exist, and when you can't really fix any more carbon dioxide and it sort of escapes into the atmosphere, the extreme greenhouse effect. But the recent research and summary of various scientific findings of the last few years from Paul Byrne suggests otherwise. It suggests that Venus is quite active even today. In other words, this beautiful planet might be a lot more mysterious than we thought originally. Now, for the longest time, scientists believed that approximately 250 to maybe 750 million years ago, Venus had a major eruption that resurfaced everything, changed the entire landscape, and since then, Venus was relatively inactive volcanically. For the longest time, scientists also believed that it might happen again sometime in the future, but not just yet. But recent research, and most importantly recent observations, kind of showed us that we were wrong. First of all, we've discovered several areas on Venus, specifically areas that you can kind of see if you look beneath the atmosphere, and usually this is done by scanning the surface of Venus with radar. Some of these surface features here are only about 250,000 years old, and that's relatively young even for a planet like Earth, because here only, like for example, islands in Hawaii or certain other regions that are currently being developed by volcanoes and by various types of volcanism are that young. And the reason we know that they're so young is because they lack weathering effects. They seem to resemble something very, very recently created. And that definitely goes against the previous theories that suggested there was no volcanism on Venus. At the same time, if you were to look around the surface of this beautiful planet, you wouldn't really find any large craters or any large formations from collisions from anything really. In other words, something seems to constantly remove craters and collisions from the surface. Now, if it's just atmospheric corrosion, it would still leave some impact signs. However, on Venus there is practically nothing, and this also suggests that there is constant resurfacing and constant change in the appearance of upper crust. In other words, most likely volcanoes. There is still probably a lot of active volcanoes. Now, we obviously haven't seen any actual eruptions like this, even though this is probably what it looks like, but we have seen the signs of past volcanic eruptions from relatively recently that may have changed the surface quite dramatically. And here's actually one of those images that was produced by one of the probes flying around Venus that indicates the surface here is somewhat young, with the obvious only explanation possible that this was done by a recent volcanic eruption. And here's one such example of a potential proof that some of the regions here are still volcanic. This object here, Idas Mons, is probably a volcano. You can see that it's a lot hotter on the inside than in the surroundings, suggesting that there is something really hot and very pressurized inside that most likely escapes once in a while and probably creates new volcanic features around this object. Now, interestingly, we don't really have a good explanation for how this happens, but it seems that it's definitely happening all over the surface. And the current estimate for the number of these volcanoes is around 1600, and that's a lot of volcanoes. That means that the entire surface of Venus will most likely change over time in the next few million years and will look completely different. And remember, here on Earth we have things like plate tectonics that usually are responsible for generating a lot of volcanism and a lot of volcanic eruptions, but how it happens on Venus is a mystery to us. There is, however, at least one explanation. At least a suggestion. So the scientists behind this study believe that instead of plate tectonics, Venus might have something like this. These circles that you see here represent mini plate tectonics. Fragments of rock literally just floating on top of the mantle, similar to how ice floats on top of water. And as these fragments float, sometimes they squeeze the surface, sometimes they stretch the surface. And this generates a lot of different activity and of course volcanoes. Very different from how it works on Earth, but this is the only explanation we have so far for what might happen or what is happening on the surface of Venus. And this also suggests that the surface of Venus is very thin, very stretchy, and very mobile. It sort of is more elasticy and a lot more flexible and bendable compared to the surface of Earth. And it is also probably filled with a lot of really interesting stuff. Now today, the scientists also believe that inside of Venus there is a large deposit of water. The reason scientists believe that is because Venus doesn't have plate tectonics, and because of that, a lot of water is trapped inside the planet. And although here on Earth, our planet has lost approximately half of its internal reserves of water, that eventually made its way to the surface and is now literally oceans here, on Venus this never happened. The water is still trapped there, and only about a quarter of the entire deposits may have escaped previously. And right now the scientists believe that at least 3/4 of Venusian water are still there inside. So this is actually good news, because one day we could potentially change the atmosphere of Venus. In other words, we could somehow terraform it, removing all of this toxic and highly dangerous atmosphere that is currently there and replace it with something nicer and more beautiful. And then, if we can find a way to somehow release this water, it will probably turn into oceans, turning Venus into a terraformed world. It would not be as challenging as Mars, because Venus already has all the prerequisites on the inside, we just have to release them. Whereas obviously Mars doesn't even have enough water or enough of anything for us to sustain a livable world on the surface unless we bring it from somewhere else. And let's actually change this a little bit so it looks a little bit more Earth-like, because I think it has way too much water. And here we go. Here's what Venus might look like if all of the water from the inside escaped and if the atmosphere wasn't so crazy hot. In other words, if we somehow remove the atmosphere of Venus and make it more habitable, this is what we expect to see. And so this particular study and this investigation actually provides really good news for the future of humanity if one day we decide to settle Venus. It essentially explains that Venus is still active. It also explains that there's most likely a lot of water hidden inside. And most importantly, it allows us to kind of dream and think about how we could maybe terraform it one day and change it into an Earth-like planet. However, unfortunately, we just don't have enough data right now to investigate anything else, because there are only 2 missions that are active on Venus. There is the Japanese Akatsuki, which struggled a little bit in the beginning, but is currently trying to study Venus a little bit more. And there is the Venus Express probe, both of which are just not producing enough data. We need to send more probes, just like we do with Mars, to try to investigate this beautiful planet and find out what we can do to make it more habitable. Even if not on the actual surface, at least maybe we could try to find a way to build some kind of a cloud city or cloud colony in the upper atmosphere of Venus, where it's actually 1 atmospheric pressure. You could totally live there except for maybe the nauseous, dangerous gases. As long as you have a mask, you should be fine.
Hello wonderful person, this is Anton, and in today's video we're going to be talking about colonization, terraforming, and potentially the future of humanity. But we're actually not going to be talking about Mars, even though I'm kind of showing it to you right now. We're going to be talking about the planet that we really need to focus on colonizing, and from the title you probably know what this planet is. So first of all, let's actually start by briefly discussing why Mars is not going to be terraformed probably ever. Now, obviously, we can colonize it, we can create quite a large underground or even above ground colony on Mars, and we can create various ways of sustaining humanity here for quite a long time. But it's just simply not terraformable for one very simple scientific reason: gravity. It just doesn't have enough surface gravity. It needs more surface gravity to permanently hold on things like oxygen, and without oxygen, you can't just have terraformed world. For this reason, unfortunately, Mars is going to be axed from the potential places where humanity can survive for the next billion or several billion years. If there's no oxygen, well, then you're gonna have to live inside big domed cities, and that's just not terraforming. But on the other hand, as you can probably tell from this title, there is a planet in our solar system that is totally capable of supporting Earth-like atmosphere. And that planet, of course, is Venus. This is the planet that we really need to consider colonizing, or basically finding a way to colonize, because it is probably the only object in our solar system right now that we could potentially call a new home in the next few hundreds of years. Now, let's actually discuss a little bit more about the problems with Venus first, and in this multi-part video I'm going to discuss some of the possible solutions we can actually try to realize. So first of all, what are the problems with Venus and why is it still not colonizable? The biggest problem, of course, is ridiculously high temperature. The temperature here is close to about 480 degrees Celsius, which of course is something that would melt most of the materials we would bring here, including things like plastics and even lead. Now, on the other hand, this high temperature could also potentially serve as a kind of a catalyst for various chemical reactions that we could initialize here to try to change the atmosphere. And that's the next problem with Venus, the atmosphere. It's actually very Earth-like, except for one part. The vast majority of atmospheric pressure on Venus comes from huge amounts of CO2. And this is what's creating so much temperature. It's the incredibly powerful greenhouse effect. So if we actually hypothetically remove all of the CO2 from the atmosphere, this will actually be a very comfortable, possibly around 3 atmospheres in pressure, atmosphere very similar to one on Earth, with just a little bit less oxygen that we can then try to create. So atmospheric pressure comes from CO2, and CO2 can definitely be removed. There's also a few other problems in the atmosphere of Venus, and one of them is huge amounts of sulfur dioxide, which can potentially be corrosive and deadly. And back in 1961, Carl Sagan actually proposed that if we genetically modify bacteria and send it to Venus and basically keep it in the atmosphere to try to break down carbon dioxide, we could potentially colonize this planet in under a decade. However, then we discovered that it wasn't just carbon dioxide here, it's also very acidic sulfur dioxide-like components, which would very likely kill most of the bacteria, but not all of the bacteria. And we'll talk about which kind of bacteria could survive here in a few minutes. Now, another problem is in regards to the rotation of Venus, and we'll actually talk about this in one of the future videos. There's also the problem of not having any magnetosphere, and that's also another problem we'll be solving in a future video. And finally, the fact that we're kind of close to the sun means that we actually receive at least a double of, and actually even more than double of solar energy that can both be a blessing and also a curse, because obviously we'll have to cool down this planet a lot more. So in today's video, we're actually going to only focus on various techniques that we can use to try to essentially change the atmosphere of Venus. And let's start with the one proposed by Carl Sagan, and that's adding some kind of a genetically modified bacteria to try to essentially reduce the atmosphere here and change it from 91 atmospheres like right now to down to about 3 atmospheres by removing the entire carbon dioxide deposits. Now, this could be done with genetically modified bacteria and also various animal-like or plant-like life that could potentially survive in super hot and super acidic temperatures. Right now, we only know of some extremophiles that could actually survive in very hot conditions, but even for them, this would be a little bit too extreme. So having extremophiles, or basically bacteria that can survive in very, very hot, very acidic conditions that could potentially survive here, but even for them, 480 degrees Celsius and super acidic conditions is maybe a little bit too much. For example, the bacteria that can survive the highest temperature right now near the hydrothermal vents under the ocean is a bacteria known as Pyrolobus fumari, but the temperature it can usually survive is about 120 degrees Celsius. There's a lot of other bacteria that can survive various conditions, so for example super high radiation and so on, but overall nothing is ready for these extreme conditions just yet, so we need to either wait and find something more extreme or possibly genetically modify them until they can actually sustain and live in super hot and super acidic conditions on Venus, and then they can help us get rid of the CO2. The alternative here is actually something that was proposed by British scientist Paul Birch, and he basically said that, well, listen, if we take a lot of hydrogen, like for example, if we were to kind of somehow find a way to transfer hydrogen from the atmosphere of Jupiter, that's right there, and if we essentially were to transfer all of this hydrogen from here and then put it on Venus, or basically not just put it, but bombard Venus with that hydrogen, we could actually completely reduce the atmosphere here and turn it into a relatively habitable planet. So using hydrogen bombardment, you can actually pretty much turn everything here into graphite, which is a type of carbon, and also water, which is something that we definitely need to survive. So hypothetically, by bombarding Venus with hydrogen, you can actually create a somewhat sustainable and actually somewhat wonderful looking world with really interesting Earth-like conditions already. A lot of carbon on the surface, a lot of water, and quite a large amount of material needed for life to live here, including for plants, of course. So a lot of carbon here can definitely be used by plants. And about 80% of the surface of Venus would actually be covered by water if we were to somehow do this. Now, obviously, the difficult part here is getting this hydrogen, delivering it here, and basically bombarding Venus with it. We don't really have that kind of technology just yet. But once we do, then sky's the limit. Alternatively, of course, you could maybe find some sort of asteroid, and potentially asteroid that actually has a lot of hydrogen in it. And essentially what you could do is launch it so that it basically collides with Venus and delivers a lot of material that way. Now, it could also potentially be used to remove atmosphere from Venus. As a matter of fact, if you could somehow collide about 1,000 objects with Venus, you could remove most of the excessive atmosphere. But even a large rock, like for example, rock the size of Makemake here at 700 kilometers in radius, would only strip Venus of about 1% of its atmosphere. That's just not enough. We would need a lot of these rocks for Venus to lose most of its atmosphere. So bombardment is a possibility, but a very expensive one, and also would require quite a lot of new technology for redirecting asteroids from the asteroid belt to Venus. And lastly, one of the other ideas comes from the paper known as The Stability of Climate on Venus, that was written back in '96. And this was by Mark Bullock and David Greenspan from University of Colorado at Boulder. And basically they proposed that, well, you could also bombard the atmosphere of Venus with other things, like for example, refined magnesium and calcium. And this would actually, I don't know what happened to my Venus. I think it just suddenly got too hot. This could actually change Venus for the better as well, reducing quite a large amount of atmospheric carbon dioxide into rocks, essentially, solidifying them into calcium deposits and leaving them on the surface as tiny pebbles. And in this case, you could actually even create factories on the surface of Venus that would basically pour out this calcium from inside the ground and use calcium from Venus to reduce its own atmosphere. But unfortunately, there's just not enough calcium and magnesium inside, so we would still need to deliver some of this by essentially colliding asteroids with Venus. So we're back to the same problem. We need to find a way to redirect asteroids. Now, before we can actually successfully redirect even a small asteroid, this is a bit of a science fiction realm. But genetically modified bacteria and bacteria that could reduce carbon dioxide and basically produce atmosphere that's a lot more habitable for humans by essentially living on the surface of Venus, surviving in hot acidic conditions, and also converting CO2 into essentially oxygen and potentially some other materials. This is something that we could definitely create in the lab today. We just need a little bit more time and research to try to develop these bacteria. Now, all in all, this is actually a good start for humanity to try to terraform planets, and I think Venus is a much better candidate than Mars. On the other hand, Venus also has about 90% of Earth gravity, so the actual surface gravity here is very similar to the one on Earth. It's about 90%. And for this reason, it's actually capable of sustaining long-term atmosphere without losing it. So that's really important for terraforming planets. Now, in the next video, we're actually going to discuss some of the other problems and issues in colonizing Venus, but for now, that's actually all I wanted to talk about. I wanted to talk about the atmosphere first. And really, the best solution, I think, is the bacteria that we can definitely create in the next few decades. And if we can actually make bacteria that can do this on Venus, we can then potentially introduce a much milder version, the one we can actually control easier, to try to reduce the CO2 level on Earth as well, because this would basically help us find a solution to the ongoing problem of increasing carbon dioxide. Currently, the levels of carbon dioxide are already above 400, and they have been increasing higher and higher every year. And reducing carbon dioxide is super important. And if we can find bacteria to do this for us, and do it quick, well, that's something we can then use on Venus. So that's kind of all for now. In the next part, we're going to discuss a few more techniques for solving some of the other problems. But for now, that's all I wanted to talk about, because it's actually a very complex idea with quite a lot of scientific discoveries, but also quite a lot of science fiction behind it. Hello wonderful person, this is Anton, and in today's video we're going to be continuing our discussion about the potential terraforming of the beautiful neighbor that we have right here, also known as Venus. Now this is often ignored in most scientific discussions, and also most sci-fi movies don't really talk about terraforming Venus as much as they do Mars. But we're going to focus on this because I personally think this is probably the best place for humanity to potentially call home in the future. In the previous part, we actually talked about changing the atmosphere of Venus, and we also talked about various chemical techniques and other scientific techniques we can use to try to basically remove the vast majority of atmosphere here, exposing the surface of Venus. If you do want to know more about it, watch the previous video, but here we're actually going to be talking about something different. Venus has another problem for us, and this is actually something that we need to fix for us to create a terrestrial planet with habitable conditions. Venus has very slow spin. So let me just actually remove this for a second. It spins extremely slow. A single day on Venus is equivalent to approximately 243 days on Earth. Because of this, there are two problems. One is that a single side is exposed to the solar radiation for about basically over 100 days, and then the other side is exposed to the dark side for over 100 days. On the other hand, except for this, there's also a problem of magnetosphere or magnetic field. The magnetosphere on Venus is non-existent, even though it does seem to have relatively similar composition to the composition of Earth. As a matter of fact, its density and its parameters are very similar, so we would expect this to have magnetic field. And we think it doesn't exist because it just doesn't spin fast enough. So, if we can somehow accelerate Venus and make it spin faster, you would probably expect things here to look a lot more Earth-like. Now, one of the reasons it's actually spinning so fast is because of its thick atmosphere. We think that over the billions of years, the atmospheric pressure here, simply due to drag, made Venus slow down its spin to the point where it's barely even moving at all. So there's several solutions to this problem, but even before I start talking about solutions, this is probably the most scientifically unachievable task right now, because removing the atmosphere is one thing, but making Venus spin faster would require quite a lot of energy. As a matter of fact, current estimates stand at approximately 50 billion petawatt hours of energy, which is approximately 1 billion times less than the entire world on Earth uses in a single year. As a matter of fact, if we were to run every single generator, TV set, computer, and PlayStation on Earth for about 1 billion years, this is how much energy we would require to basically accelerate the rotation of Venus to that of Earth. On the other hand, this is also the same amount of energy that our Sun, which is right there in the distance, produces in about 10 minutes. So on one side, it's kind of a lot of energy, but on the other side, we actually do have a generator right there that can potentially create enough energy to make Venus spin faster. Now, one of the first techniques we're going to discuss here is relatively obvious. So here, we're actually going to just take a look at our current rotations, 243 days. The more obvious technique is basically colliding things with Venus and basically colliding them with the side where it would actually kind of increase the rotation. And so here, okay, that actually decreased the rotation, 246 days. I put it on the wrong side. Let's try it again. Here, we're using Pallas to basically try to increase the rotation speed on it. With one single collision, it actually already improved it by 1/3. So here we have 72 days rotation speed. On the other hand, what you could actually do, and this is a little bit more realistic than just colliding things with Venus, is to launch thousands of smaller asteroids, basically redirect smaller asteroids, and make them move really, really fast and basically fly by Venus instead of colliding with Venus. So here, with this every single flyby, there's going to be an energy transfer between Venus and the object passing next to Venus. And if we do this enough times, we'll actually make Venus spin faster and faster. So here, an object that's relatively massive, that passes by Venus relatively close to its surface, is actually going to gravitationally influence its rotation, and as long as it passes on the right side, is going to basically make it spin a little bit faster. So now if I take a look at it again, its rotation will have increased, or I guess decreased, to 70.3 days. So we just gained about 2 days of rotation. Or I guess it basically made it spin a little bit faster. And if you do this thousands of times, you can basically bring this down to approximately 1 day per day. In other words, you can make it more Earth-like. So that's the solution that's a little bit more realistic than just colliding things with Venus, because redirecting asteroids is not a very impossible task. We think that we are going to be capable of redirecting an asteroid in the next few decades. And so if you do this thousands of times, eventually Venus might actually start spinning faster and faster. On the other hand, if we actually launch several smaller asteroids but make them move way, way faster at several thousands kilometers per second, and that's of course using some sort of ion drive propulsion or something else that will increase their speed constantly, we could then use a lot less objects and also smaller objects, but would probably require some sort of a technology to have constant acceleration of these asteroids toward Venus. So that's basically a second technique, using close pass-bys to slowly accelerate the rotation of Venus. And the last technique I was going to discuss is, or would require something to be installed on the surface of Venus first. And here we're talking about the so-called mass drivers. These are basically, here's a picture of one. These are very, very large accelerators of matter. And these accelerators can often increase the velocity of something up to about 10% of the speed of light. So hypothetically, and this is actually still in the realm of science fiction, but we already have some of these on Earth, so we might as well try to find a way to create them on Venus. If you were to install a very, very massive mass driver on the surface of Venus, and then somehow use the atmosphere of Venus to basically get injected into the mass driver and then get shot out of it at ridiculously fast speeds, we could then maybe use these mass drivers to accelerate the spin of Venus to the point where it's going to spin just as fast as Earth. Now, this technique is definitely science fiction for now, but here's the thing. Not only will this actually make Venus spin faster, but it will also get rid of the huge atmospheric pressure. So you could technically remove all 90 atmospheres of pressure from Venus and at the same time accelerate its rotation. As long as you can create these mass drivers on the surface, this would potentially solve two problems within just about a year, maybe even less. And as long as we can actually increase the speed of Venus, we can then start thinking about everything else, including, of course, hopefully reestablishing the magnetosphere here, re-enabling the carbon exchange cycle, and creating something that seems to resemble more Earth-like features and also more Earth-like surface, atmosphere, and pressure. And this is basically, I personally think, one of the more important steps for us. As long as we can make it spin faster, we'll solve a lot of problems. On the other hand, relatively recent studies actually did show that you could potentially have terraformed Venus even without the fast spin. Using a variety of techniques such as, for example, orbital mirrors, you could project light on the other side, and using various techniques like thick cloud layers or an object placed in between the Sun and Venus in one of the Lagrange points to basically block the Sun would maybe make it a little bit easier to live on by reducing sunlight on the bright side and increasing sunlight on the dark side. Now, these techniques are still in planning, and a lot of them are still relatively theoretical, but they are possible and would definitely potentially create worlds that we could then live on in the next few millions and maybe even billions of years, until the Sun expands and absorbs it. Anyway, that's all I wanted to talk about in this video, and hopefully you learned a little bit more about terraforming of Venus in it. And if you do have any other ideas about how we could potentially terraform Venus, please post it in the comments below, and in one of the future videos we're going to bring it all together and possibly terraform it once and for all, creating some kind of a livable world, at least in Universe Sandbox.
I'll see you tomorrow. Space out, and as always, bye bye.